Hello and welcome to Sleepy Science. I'm truly glad you're here. Whether your day has been noisy or your thoughts are still swirling like galaxies, this is your quiet space to unwind. Tonight, we'll gently drift into the strangest ideas ever whispered by science. Not just theories, but possibilities so wild they tiptoe on the edge of dreams. What if you never truly die? What if you only exist when someone looks? What if time has more directions than forward? Or aliens are already here, but we just can't perceive them? In this slow, soft journey, we'll explore the idea that consciousness might be baked into space itself, that memories may not live in your brain, and that reality could be a self-simulating illusion built from math and mind. Don't worry. Nothing loud, nothing rushed. Just a gentle stream of wonder, meant to calm your breath while sparking awe in your heart. Before we begin, I'd love to know, where are you listening from tonight? Are you curled up under stars, or tucked into the warmth of your room, ready to let go of the day? If videos like this help you rest, or simply remind you how weird and wonderful it all is, feel free to like and subscribe. It truly helps more quiet thinkers find their way here. Now, take a deep breath, and let's begin our silent fall into the strange, the invisible, and the maybe true. Quantum immortality. You might never die in the version that matters. What if dying doesn't mean what you think it means? Not because of hope, myth, or magic, but because of how the universe truly works at its smallest, most fundamental level. Imagine you're playing a video game, where each time your character is supposed to die, the screen glitches for just a moment, and suddenly you're still standing, unharmed, in another version of the world. Everything feels the same, but deep down you know something changed. Now imagine that this isn't a fantasy, but a real idea in quantum physics called quantum immortality, one that quietly challenges the very meaning of death itself. Not for everyone, not in a Hollywood way, but perhaps just for you. To begin understanding it, we first need to talk about how the universe behaves at the quantum level. The realm of atoms and particles so small, you could line up 1,000,000 of them on the edge of a pin. In this strange microscopic world, things don't follow the clear rules we're used to in daily life. A particle doesn't just go left or right, it goes both ways at once. A cat isn't just dead or alive, it's in a fuzzy blur of both, until someone looks. This is called quantum superposition, and it means that the universe doesn't pick a single outcome until something interacts with it. When you measure, observe, or just happen to be part of the system, the possibilities collapse into one reality. This may sound like science fiction, but it is backed by real experiments, such as the double-slit experiment, where particles seem to take every possible path until they're observed. Now here's where things get truly strange. Imagine that in a situation where you might die, a car crash, a medical condition, anything with a chance of survival, there are versions of the universe where you do die, and others where you survive, according to a theory called the many worlds interpretation, which is a real and respected view in quantum mechanics. Every possible outcome actually happens, but in different branches of the universe splits again and again endlessly. And you, the person reading or listening to this, might only be aware of the branches where you survive. In other words, in every moment where your death is possible, but not certain, your consciousness might continue in the one version where you make it. The versions where you don't, they still happen, but you are no longer aware of them. This is the seed of the quantum immortality idea. Not a magical escape from death, but a curious suggestion that subjectively, your experience of being alive might never include your own death. From the inside, you may always be the version that made it through. It is a little like flipping a coin, but in one universe it lands heads, and you trip, and in another, it's tails, and you keep walking. And somehow, your awareness always follows the path where you keep going. Now, let's be clear. This doesn't mean you're invincible, or that you'll live forever in the way we normally imagine. Everyone else would still see you age, decline, and eventually pass. From their point of view, death happens. But from your point of view, in the branch of the universe that keeps your consciousness going, you just continue. To what end, no one knows. It might mean surviving against all odds over and over. It might mean waking up from situations that seemed hopeless, or perhaps, in some far future version, it means existing in a world where medical science has advanced so much that your death gets delayed again and again. The key here isn't fantasy, it's perspective. Quantum immortality is not about escaping death universally. It's about the bizarre possibility that your subjective consciousness may never witness its own ending. That as long as there is even the tiniest probability of survival, there's always a version of the universe where you keep going. And that's the one you're aware of. But does this mean we should stop fearing death? Not exactly. Because even if you might never notice the moment of dying, those around you still do. And if this strange idea is true, it doesn't remove pain or aging or loss. It only challenges the finality of those things in your own personal stream of awareness. It raises questions instead of answering them. What does it mean to die? If you never experience it, what does you even mean in a universe constantly branching? Are you the same person across every survival? Or are you diverging, subtly different, like echoes across space? Some critics argue that quantum immortality is unfalsifiable, that we can't test it, and so it shouldn't be considered science. But others point out that it naturally follows from existing quantum principles. If you take the many worlds interpretation seriously, and while no one has proven it, its implications are worth considering, because they speak to the heart of what it means to be alive and what it means to vanish. We often think of death as the one thing that levels us all, but if consciousness always clings to the thread of survival, even improbably, then your awareness might be far more resilient than you imagined. Still, even this resilience has limits. The theory doesn't claim you'd live well forever. You might find yourself endlessly aging, increasingly fragile, or surviving catastrophes only to face new ones. Some versions of the theory grow darker as you follow them. What if you never die, but keep living into a stretched twilight of discomfort, decay, and confusion? That's why quantum immortality isn't necessarily comforting. It's not an escape. It's a thought experiment. One that forces you to ask if you had to keep living no matter what. How would you live? Would you make your time meaningful? Would you treat your body, your relationships, your memories with more care? Would you stop wasting the moments you have, knowing that somewhere they continue? And perhaps, in the end, that's the real gift of this idea. Not that it promises immortality, but that it challenges you to imagine a life where each survival carries weight, where each moment is not just lucky, but selected, where you are the outcome of endless near-deaths, chosen again and again by the strangest laws in nature to keep going. You're not promised forever. You're just here, still breathing, still wondering, still alive, and maybe that's enough. Because even if the universe splits 1,000,000 times, the version that matters most is the one where you're reading this sentence right now. Aliens might already be here, but exist outside our perception range. What if the question isn't whether aliens exist, but whether we're even capable of noticing them? Imagine standing in a room full of conversations, but every voice is speaking a language your ears can't hear, a frequency just outside your range, or using signals you were never built to detect. Wouldn't it feel like silence? That's the haunting possibility explored by some scientists and thinkers. That extraterrestrial life isn't necessarily absent, just inaccessible. Already here, perhaps even close, but existing in forms, wavelengths, dimensions, or behaviors that slip completely beneath our notice. The idea might sound outlandish at first, but it's grounded in a simple truth. Our senses and instruments are limited, sharply tuned only to a narrow band of reality. Our eyes can see just a sliver of the electromagnetic spectrum. We can't perceive ultraviolet or infrared without special devices. Dogs hear sounds we miss. Birds sense magnetic fields. Bees see polarized light. The world is already far richer than we can naturally experience, And yet we often assume that if something important is out there, we'd be able to spot it. But what if that assumption is wrong? What if the forms of life that might visit, or already have, don't move in metal ships, don't speak in radio waves, and don't conform to the patterns we expect? For decades, scientists have searched for aliens by scanning the skies for signals, radio waves, bursts of light, patterns that resemble our own communication. But this search depends on a huge assumption, that aliens think like we do, that they use similar technology, and that they'd want to be found in the first place. What if their version of technology is entirely different, not made of metal and circuits, but of biology, light, gravity, or even forms of physics we haven't discovered yet? We once believed that life required Earth, like conditions, water, oxygen, a rocky surface, a narrow temperature range. But extremophiles, organisms that live in boiling acid, freezing methane, or radioactive waste, have shattered that belief. Life, it turns out, is adaptable, resilient, and wildly inventive. If life can exist at the bottom of a toxic ocean, or inside a radioactive rock on Earth, why couldn't it take forms in other environments so strange that we wouldn't even recognize them as alive? Some researchers have even proposed that alien life might not be carbon-based at all. It could be silicon-based, plasma-based, or exist as electromagnetic fields that flicker like thoughts through magnetic storms. There's even the idea of shadow biospheres, forms of life that evolved separately right here on Earth, but that don't interact chemically with our kind, making them invisible to our biology-focused tools. And if our own planet might host unnoticed life, what does that say about the cosmos? We look at Mars, Europa, or distant exoplanets for familiar patterns, atmospheres like ours, chemical traces we recognize. But that's like searching for birds by listening only for human speech. What if we're missing the music completely, simply because we don't know how to hear it? Now shift the focus back to Earth. Not the telescopes pointed outward, but the strange stories that have circled among us for generations. Pilots reporting objects that outrun jets. People describing entities that don't quite look like anything familiar. Military encounters with fast-moving direction, changing shapes that leave no exhaust, no radar trace, no explanation. While many such accounts are speculative, the growing body of officially released footage, such as the US Navy's Tic Tac videos, shows real confirmed aerial phenomena that defy known human technology. These are not proof of aliens, but they are proof of limits in our understanding. Something is moving through our skies, and we don't know what it is. Skeptics suggest glitches, equipment failures, or foreign drones. And some of those explanations are reasonable, but others leave experts baffled. Could it be that what we're seeing isn't necessarily from far away, but from close by, just slightly out of phase with our perception, slipping between what we call real and imagined, physical and non-physical? Consider this. We think of reality as solid and shared, but most of what we know about the world comes through interpretation. Your brain doesn't show you the world as it is, it reconstructs it. If a presence existed just outside our perceptual boundary, too fast, too subtle, too differently structured, would we call it not real? Or would we admit we're just not equipped to see it? Some researchers have considered the possibility that alien intelligence might exist on a completely different cognitive timeline. What if they think 1,000 times slower than we do, or 1,000,000 times faster? A creature whose thoughts take centuries wouldn't notice us, just as we wouldn't notice creatures whose entire life cycle fits in a blink. We often talk about space as the barrier, but maybe it's time that separates us. And what if intelligent life isn't individual at all, but collective? What if it doesn't build ships and cities, but spreads like a field, consciousness distributed across clouds, oceans, electromagnetic pulses? Such beings wouldn't send messages in bottles, they are the ocean. Would we recognize such a thing as our lives here? There's also the question of motive. We assume that intelligent life would want to communicate with us, that it would reach out the way we do, transmit, signal, explain. But maybe that's projection, maybe intelligence, advanced enough, has no interest in contact, or already tried, and moved on when we didn't respond in time. Or maybe the contact is ongoing, just not in the way we expect. Some people talk about inspiration, dreams, synchronicities. While science doesn't rely on feelings, it also doesn't rule out phenomena, simply because they don't fit the current model. If alien life were subtle, emerging through influence rather than arrival, would we even know it? There are also serious theoretical discussions about dimensions beyond our own. We experience 3 dimensions of space and 1 of time. But string theory and other advanced models suggest there could be many more, folded up, hidden, curled inside the universe like unseen seams. If another intelligence evolved in or adapted to those dimensions, they wouldn't need to arrive from another star. They could already be here, moving through folded corridors of reality we don't yet understand. Just as a 2-dimensional being couldn't see someone stepping over their flat world, we might be unable to perceive entities operating through higher dimensional space. Their absence might be nothing more than our inability to look up. Combine this with quantum physics, where particles can be entangled across space or exist in superpositions of multiple states, and you begin to see that reality itself is not as solid as we once thought. Could consciousness, intention, or life itself ride along these strange rules, emerging in forms that shimmer just beyond our grasp? To be clear, none of this proves aliens are here, but it shifts the question from "where are they?" to "what are we capable of noticing?" The famous Fermi paradox, the question of why, in a universe so vast, we haven't seen clear signs of life, assumes that life would be detectable in ways we understand. But what if it's not? What if life is common, but silent? Or common, but misinterpreted? Or present, but deliberately hidden? The zoo hypothesis proposes that we're being observed, like animals behind one-way glass, studied until we're ready. Again, it's not proof, but it raises an important philosophical question. Are we truly looking, or just expecting mirrors? Expecting ourselves? In the end, maybe the alien is not a grey figure in a flying saucer. Maybe it's a form of intelligence that doesn't fit in our boxes, a way of being that doesn't build cities, but influences patterns. A life that moves not in steps, but in probability waves. If that's true, then maybe they've been here the whole time, watching, wondering, or simply coexisting in a way we've never imagined. And maybe, just maybe, the first real contact won't come through a telescope, but through a shift in how we define perception itself. Not by stretching further, but by seeing deeper. Because in a world where we already miss so much, colors we can't see, sounds we can't hear, life forms that hide in plain sight, it's not hard to imagine that we're surrounded by strangeness, that we've mistaken silence for absence, that what we call alone might only be a reflection of our limitations, and that the truth, quiet as it may be, has been here all along, just outside the edge of what we're able to see. The moon may be artificial, oddities in its formation and orbit. Not all mysteries lie in distant galaxies. Some are right above our heads, glowing quietly in the night sky, so familiar we forget to question them. And yet, the moon, the very object we see almost every night, is one of the strangest things in the entire solar system, hiding so many peculiar traits that some scientists and skeptics alike have dared to ask, could it be artificial? Let's be clear from the start. We're not talking about spaceships or hollow metal moons controlled by aliens, but we are talking about patterns and facts so unusual that even seasoned astronomers raise their eyebrows. Because the moon doesn't behave the way a natural satellite should, and its very existence, when you dig into the details, becomes a quiet enigma. First, there's its size and position. It's 400 times smaller than our star. Yet it also happens to be 400 times closer to Earth, which means from our perspective, they appear the same size in the sky, allowing for perfect total solar eclipses, where the moon covers our star with eerie precision. This isn't just beautiful, it's mathematically stunning. There's no reason these ratios should line up like that. And yet they do, almost too neatly. Some call it coincidence. But such a cosmic coincidence, unique in our solar system, raises questions that don't have easy answers. And it doesn't stop there. The moon is way too big for the Earth. Most moons are tiny compared to the planets they orbit. But our moon is about a quarter the size of Earth, making the Earth-Fey-Moon system more like a double planet than a typical planet-Fey-Moon pair. This abnormal size gives the moon enormous influence. It stabilizes Earth's tilt, creates tides, and may even have made life on Earth more likely. But where did it come from? Scientists once believed the moon formed alongside Earth, but its composition doesn't match. Its crust has strange isotopes. Its rocks are much drier than expected. And the lack of iron in its core makes it lighter than it should be. The current leading theory, called the giant impact hypothesis, suggests that a Mars-sized object named Theia collided with Earth billions of years ago, and the debris eventually formed the moon. It sounds neat, but there's a problem. Simulations show that most of the moon should have come from Theia. And yet moon rocks look almost exactly like Earth's outer layers, as if Theia left barely any mark at all. That's suspicious. And then there's the orbit. Unlike most moons, which orbit along their planet's equator, the moon orbits in a tilted plane that doesn't align with Earth's equator or the solar system's original disk. It's as if the moon was placed in orbit, or at least captured, in a way we don't fully understand. But here's where it gets even more curious. The moon's center of mass is not at its geometric center. It's offset, shifted toward Earth. This asymmetry is rare and makes its rotation and orbit more stable. Again, good for life, but odd for a supposedly natural object. And when we sent seismometers to the moon during the Apollo missions, they detected something weird. The moon rang like a bell during shallow moonquakes, vibrations that echoed much longer than expected, suggesting a rigid outer shell and possibly a less dense interior. Some speculated this could mean the moon is partially hollow, not in a science fiction sense, but as a geophysical anomaly. Hollow planets or moons are not stable in most models. So if our moon behaves like one, we have to ask why. Then, there's the dust. The regolith, that soft grey surface, contains unusual materials, including pure titanium and strange glass beads that form under intense heat, as well as helium-3, a rare isotope that could be useful for future nuclear fusion on Earth. But where did these elements come from in such abundance? The moon lacks volcanic activity today, and its magnetic field is weak. So many of these materials shouldn't be so prevalent near the surface, unless something unusual brought them there or preserved them. Even stranger, some of the moon's craters are too shallow. Given the size of the impactors, the surface should show more depth. This hints at either some kind of hardened layer beneath, or a resistance to penetration that we don't yet understand. In the 1970s, two Soviet scientists, Vasin and Shabakov, went as far as to publish a paper speculating that the moon could be an ancient, hollowed-out planetoid, perhaps engineered in deep time by unknown intelligence. That sounds like science fiction, and it is. There's no direct evidence supporting artificial construction. But the point is this: the moon is so unusual that even serious scientists have found themselves straying into speculative territory, not because they want to, but because the facts are that odd. And yet, most people don't know any of this. We grow up with bedtime stories and soft lullabies about the moon, but we're rarely told how deeply strange it is. That it shouldn't be this big or this close, or this perfectly aligned, that its rock samples puzzle geologists, that its orbit is eccentric and its behavior unique. It has no magnetic field of its own, yet it contains magnetized rocks. It causes tides that shape ecosystems, and yet is drifting slowly away from Earth, millimeter by millimeter, changing the future of our planet. It lights our night skies and affects our sleep cycles. In every sense, the moon is not just an object in the sky. It's a silent partner in Earth's story, an architect of rhythms, a stabilizer of seasons, and a mirror of our curiosity. Whether it's artificial or not may never be known for certain. The majority of scientists favor natural explanations, and rightfully so. They're simpler, less dramatic, and backed by models that mostly work. But even among the mainstream, there is quiet agreement. The moon's origin remains one of the biggest unsolved problems in planetary science. So what does this mean for us? Not that we should believe in secret moon bases or alien construction crews, but that we should never lose our sense of curiosity, especially about the things we think we already understand. The moon is visible to nearly every human who's ever lived, and yet we're still asking basic questions about where it came from and what it's made of. That's not failure, that's wonder. And it reminds us that mystery isn't a sign of ignorance. It's the starting point of discovery. You don't have to believe the moon is artificial to be amazed by how strange it truly is. All you need is a willingness to look at what's familiar and realize how little we still know. Because sometimes, the most alien thing isn't out there in another galaxy, it's right above us. Hiding in plain sight, glowing softly with questions we've only just begun to ask. You might only exist when observed quantum solipsism. What if the world doesn't exist when you're not looking at it? Not as a fantasy, but as a real possibility hinted at by some of the strangest and most serious physics ever discovered. It sounds absurd, maybe even egotistical, to imagine that your observation might somehow bring reality into being. But deep inside the mathematics of quantum mechanics, there's a weird and haunting idea that refuses to go away. What if you and everything you know only take shape when something or someone is watching? This isn't a thought experiment about vanity or imagination. It's called quantum solipsism, and it comes from very real features of our best understanding of how the universe works at its most fundamental level. Let's start with what physicists have observed. In the tiny world of particles like electrons and photons, things don't behave like they do in everyday life. A particle doesn't have a definite position or momentum until it's measured. It exists in a state of possibilities, a superposition, meaning it can be in many places or states at once. But the moment you try to detect it, that cloud of probabilities collapses into one outcome. Suddenly, it is somewhere. Suddenly, it has a direction. This isn't a metaphor, it's what happens in labs around the world. And it has been confirmed by experiments again and again, most famously in the double-slit experiment, where light acts like a wave when unobserved, but like a particle when watched. Observation changes the outcome. But why? Why does the act of measurement, just looking, alter what's real? No one knows for sure. But one interpretation, as unsettling as it is fascinating, suggests that consciousness itself may play a role in shaping reality. That, until a conscious observer steps in, the world isn't locked into one specific version. This brings us to the terrifying and mesmerizing idea of quantum solipsism, that the reality you experience is tied directly to your observation, and possibly that you only exist when being observed. In philosophy, solipsism is the belief that only your own mind is certain to exist. Everything else, people, objects, even time, could be illusions. Quantum solipsism borrows that idea but anchors it to physics. It asks, what if the universe doesn't resolve into reality until it's observed? And what if you, as a conscious observer, are the only reference point where that resolution happens? What if your experience of being alive is just a sequence of collapsing probabilities, all stitched together by attention? Think of it like this. When you turn off a video game and the screen goes black, the world inside the game stops rendering. It doesn't continue somewhere, unwatched. Could reality be the same? Could unobserved parts of the universe be paused, undefined, unformed, waiting for someone to look? Some interpretations of quantum mechanics, like the participatory anthropic principle, propose that observers are not just passive spectators, but necessary players. That we don't just discover the universe, we help create it by observing it. That existence, in some deep way, requires consciousness to make it real. Not because you're special, but because that's how the fabric of the universe might be stitched together. This isn't to say that you, personally, are conjuring reality with your thoughts like a wizard. It's subtler and stranger than that. Your observation might be just one of countless such acts happening across the cosmos, all weaving together what we call reality. But here's where it gets unsettling. If observation is required for something to be real, then what happens when no one is looking? What's the status of the moon when no mind is thinking about it? Or a tree falling in the forest with no one around? Does it actually fall? This ancient philosophical riddle gains new teeth in light of quantum physics. In one interpretation, the universe is filled with probabilities, and only conscious interaction collapses those into definite events. In another, there's a vast branching multiverse, and observation just determines which version you fall into. But in the more radical versions, nothing is definite until awareness touches it, and that makes you wonder, how far does this go? Could it apply to your memories, your body, your own identity? What are you before you are observed? By others, by yourself. We know from neuroscience that our brains are filled with blind spots and reconstructions, that even our vision is a post-processed, edited story. So if even your perception of the world is a guess built from partial data, could your sense of self be the same? If observation is required to finalize reality, maybe your identity is something constantly being collapsed into existence. Not something fixed, but something fluid, reconstructed moment by moment as you interact with the world. And maybe, when you're alone, unobserved, in the deepest quiet, your self becomes more probabilistic, less defined, a kind of emotional superposition where you are many things at once, brave and scared, wise and lost, here and not here. In this view, consciousness becomes a mirror turned in on itself, always collapsing its own reflection, always updating the illusion of stability. And suddenly, the solid world we take for granted feels more like a shared dream, a quantum hallucination made real by mutual observation. It's worth noting that not all scientists agree with this idea. Many prefer interpretations where the universe is fully real and defined regardless of who's watching. But the reason quantum solipsism won't die is because the math allows for it, and because we've never truly resolved the role of the observer in quantum mechanics. Some physicists have tried to remove consciousness from the equation, inventing mechanisms like decoherence, which say that interaction with the environment, not minds, causes the collapse of probabilities. But even those approaches struggle to explain why measurement feels so special. Why can you run an experiment 1,000,000 times and only see the particle take one path each time? Why does it choose? And what is doing the choosing? No one knows. And that mystery leaves the door open, because until we understand how observation works and what role consciousness plays in it, we can't dismiss the possibility that reality itself is observer-dependent, that your experience of being alive is the only true anchor in a sea of uncertainty. Now pause and think about the emotional side of this. What does it mean if you only exist, fully exist, when being seen, not just by others, but by yourself? It brings to mind our deepest human needs: to be noticed, to be understood, to be loved. Could our craving for connection, for validation, for being seen, be more than emotional? Could it be quantum? Maybe when someone looks at you with full attention, they're doing more than comforting you. They're helping you collapse into reality, giving structure to your existence. And maybe that's why isolation feels so scary. Not because you're physically alone, but because something inside you starts to dissolve, to feel less real. If observation is existence, then love, the act of truly witnessing someone, becomes a form of creation. And so does memory. When you remember someone who's gone, maybe part of them flickers back into definition, not as a ghost, but as a kind of quantum echo, of course. All of this is speculative. But speculation isn't the same as fiction. It's what happens when science gets close to the edge of what it can explain and starts asking deeper questions. And those questions are what make quantum solipsism so powerful. Not because it tells us how things are, but because it invites us to wonder, what if the answer isn't found in particles or galaxies, but in the quiet act of seeing, of noticing, of being aware? And what if that awareness is the most real thing there is? Not mass, not energy, but observation. The thing that makes the world choose a shape. So the next time you look into a mirror and wonder who you are, or feel unseen in a crowded room, or close your eyes and feel yourself blur into thought, remember this: you might only exist in the way that matters when you are observed, but that observation doesn't have to come from others. It can come from within, from your attention, from your intention, from your choice to be here, now, aware. And maybe that's the secret, that in a universe of endless possibilities, it's not the things we touch that are most real. It's the moments we notice, the ones we bring into being simply by choosing to look. You might be in a dream right now and never notice it. What if everything around you right now, your room, your thoughts, the sound of this voice, was just part of a dream and you had no idea you were dreaming? That might sound like the start of a science fiction story, or maybe the plot of a movie you've seen, because even though you feel awake and everything seems solid and real, there's no absolute way to prove that what you're experiencing is not just a mental simulation, a vivid construction of your own mind. Think about the dreams you have when you sleep, how real they feel while you're in them. In dreams, you don't usually realize you're dreaming. The people, the places, even the logic of what's happening all feel normal until you wake up and say, "Wait, that was so strange." But in the moment, it felt real. And that's the problem. Our brains are really good at creating convincing realities, whether we're asleep or awake. So here's the hard question. How do you really know the difference between dreaming and being awake? This isn't just a philosophical puzzle, it's also a scientific one. Neuroscientists have discovered that the same areas of the brain that light up when you're awake are also active during dreams. The brain doesn't treat dreams as less real than waking life in terms of processing sensations, emotions, and even logic. The images you see in dreams, the sounds you hear, the people you talk to, they are all produced by the brain without any input from the outside world. And yet, they feel completely real in the moment. That's because what you experience as reality is actually a model your brain builds from sensory data. Your eyes take in light, your ears take in sound, your skin feels pressure, but it's your brain that assembles all that into the picture of a world. In dreams, the brain skips the sensory input and creates the world from scratch. But your conscious mind doesn't always notice the difference, because your awareness doesn't come with a built-in warning label. It doesn't say, "You're dreaming now." It just feels real, which means if your brain can trick you into thinking a dream is real, who's to say it isn't doing that right now? One of the strangest things about dreams is that we usually don't question them. In a dream, it can be completely normal to talk to a cat who gives you homework, or fly across a city made of jelly beans. You don't stop and say, "Wait, this is nonsense." That part of your brain that analyzes and checks for logic, the prefrontal cortex, is often less active in dreams. But sometimes, in a special kind of dream called a lucid dream, that part of your brain wakes up. You suddenly realize, "I'm dreaming." And the moment you become aware, everything changes. You might take control of the dream, fly at will, reshape the environment. It becomes a kind of virtual reality playground, where you're both the director and the actor. But that rare shift, where you become aware of the illusion, is a powerful clue. Because if it's possible to wake up inside a dream, what if there's another level of awakening beyond what we call waking life? What if, just like in dreams, you're going through your day assuming it's all real, but you've never actually questioned it? Now, let's ask another question. Why would your brain create an illusion? The answer is, it always does. Even when you're awake, you don't experience the world directly. You experience a version of the world, filtered through your senses. shaped by your expectations, colored by your memories, and edited by your attention. If you walk into a room looking for your keys, you might miss a giant red balloon floating in the corner. Just because your brain filters it out as irrelevant, that's not science fiction. It's a well-studied phenomenon called inattentional blindness. So in a way, your brain is already creating a kind of waking dream, a version of reality that's useful, not necessarily accurate. It shows you what it thinks you need to see, not what's truly there, and that opens a deeper mystery. If your waking life is already filtered, constructed, and partly imagined, where is the line between dreaming and reality? Is it possible that what you think is solid and permanent is just another layer of illusion? This brings us to one of the most unsettling ideas in both science and philosophy, that reality might be indistinguishable from a dream, not because it's fake, but because your experience of it is always mediated by your mind. This doesn't mean that nothing is real or that life is meaningless. It means that what you call real is always a product of interpretation, and that interpretation can be wrong, limited, or even fully fabricated. Think of virtual reality. If you put on a headset that stimulates your senses well enough, you can believe you're somewhere else entirely. The technology isn't perfect yet, but it's getting better every year. Now imagine a dream or a hallucination that's perfect. One that stimulates all your senses, matches your expectations, follows believable physics, and gives you a sense of time, memory, and self. Would you be able to tell it apart from real life? And if not, how can you ever be sure that this, right now, isn't something like that? Some scientists believe consciousness itself is a kind of dream engine, an ongoing hallucination that your brain uses to make sense of everything. The famous neuroscientist Anil Seth calls it a controlled hallucination, where the brain constantly predicts what's happening next and adjusts its model based on feedback. In other words, you don't see the world as it is. You see what your brain thinks the world is, and updates it as needed. That model works most of the time. But like all models, it can be fooled. Even the feeling of being you, your sense of self, is a construction, built from sensory information, emotions, and memories. And just like dreams, it can shift or vanish in extreme conditions, under anesthesia, in deep meditation, or during certain brain disorders. So what if your waking self is just another layer of dreaming, one that feels more stable, but is just as constructed? Philosophers have wrestled with this for centuries. The French thinker René Descartes famously asked how we can ever be sure we're not dreaming. He concluded that the only thing he could be absolutely certain of was the act of thinking itself. I think, therefore I am. But even that might not be safe, because if your thoughts too are part of a dream, then even the idea of being might be an illusion. Today, some scientists explore similar questions using brain scans, consciousness research, and simulations. We know, for example, that people can be placed into false awakening loops, a phenomenon where someone wakes up from a dream, only to discover they're still dreaming, and it can happen again and again. Imagine waking up 5 times, only to realize each time that you're still asleep. If your brain can fool you once, twice, or 5 times, why not forever? Why not now? Of course, we don't live our lives as if everything is a dream. We act, love, struggle, and hope as if our choices matter, and maybe they do. But asking, what is real, isn't about giving up on meaning. It's about recognizing how fragile and precious awareness is. If this moment is a dream, it's a beautifully detailed one, full of color, memory, emotion, and consequence. Maybe that's the point. Even if you're dreaming, the dream feels real, and that feeling is enough to care, to feel joy and pain, to learn and grow. But what if you could wake up just a little more, become just a little more aware? Would your life look different? Would you notice things you've never seen before? Maybe, like a lucid dreamer, you could shape your reality more actively. Maybe awareness itself is the tool that turns a passive illusion into an active creation. So let's imagine just for a moment that you're still dreaming. What would you do differently, knowing that none of this is guaranteed, that all of it might be imagined? Would you pay closer attention to the people around you? Would you cherish the sensations, the colors, the sounds? Would you listen more deeply to your own thoughts? You don't have to believe reality is fake to live with more wonder. You just have to realize that your experience of the world is a miracle of interpretation, a fragile theater of consciousness that could vanish in a blink. And in that awareness, there's freedom. Not to escape reality, but to embrace it fully as the one dream you can shape. Because whether this is a dream or not, you're here now and you're listening. And that means, for this moment at least, something real is happening. Consciousness could be a fundamental force of the universe. What if the universe didn't just contain consciousness, but needed it? What if awareness wasn't something that emerged after billions of years, but something that was there from the beginning, woven into the fabric of existence itself, like gravity or time? This idea might sound strange at first, especially since we usually think of consciousness as a byproduct of biology, something that arises in brains after long evolutionary processes, like a light flickering on when the right wiring clicks into place. But what if we've been looking at it backwards? Instead of seeing consciousness as something that emerges from matter, some scientists and philosophers are starting to ask a more radical question. What if matter itself is shaped by consciousness, or even depends on it? This shift isn't just a poetic reversal. It's a serious challenge to the standard view in science that says the universe is a giant machine, unconscious and indifferent, running on cold equations, with awareness being a late, accidental side effect. But growing evidence from quantum physics, information theory, and even neuroscience suggests we might be missing something enormous. The possibility that consciousness is not the end of the chain, but the beginning, or at least a central part of how reality operates. Imagine a world where consciousness is as fundamental as space, as real as mass, as present as energy, not a glitch, not a fluke, but a force. This is the question we'll gently explore tonight. Not to prove, but to wonder, to think differently, and maybe even to feel something shift. Let's begin simply. When you open your eyes in the morning and see light pour in through the window, when you hear a bird sing or feel your breath move in and out, there's something quietly astonishing happening. You are aware of it. You're not just reacting like a machine, you're experiencing it. There's a you inside the moment, and that awareness, that inner spark that knows it's alive, is something no one fully understands. Scientists know how to measure brain activity, map neural circuits, and observe how different chemicals affect emotions and memory. But the feeling of being you, the raw sensation of being conscious, remains a mystery so deep, it's sometimes called the hard problem of consciousness. Because no matter how much we learn about the brain, we still don't know why it feels like anything to be a person. Why aren't we just walking computers? Why is there an inner world at all? And here's where the shift begins. Instead of assuming that consciousness needs a brain to exist, some theories suggest that brains are just one way of focusing consciousness. Like a radio tunes into waves that are already everywhere, but doesn't create them. This is where physics enters the conversation in a surprising way. In quantum mechanics, the branch of science that studies the tiniest building blocks of reality, there's a strange rule. Particles don't seem to take on definite states until they are measured or observed. Before that, they exist in a kind of cloud of possibilities, called a superposition. Only when a measurement occurs does the particle decide, on a single position, like a coin flipping through the air, suddenly landing heads or tails. But here's the mystery: what counts as a measurement? And why does observation seem to change what reality is? For decades, physicists have wrestled with this problem. Some believe it's just a quirk of the math. Others, like Nobel Prize winner Eugene Wigner, have asked whether consciousness itself might be the missing piece. In Wigner's view, it wasn't the measuring device that changed the system. It was the mind interpreting the result. If that's true, then consciousness isn't just a passive mirror reflecting the universe. It's an active participant, possibly even a necessary ingredient for the universe to have definite properties at all. In other words, things become real because they are experienced. This idea leads to something called panpsychism, a theory that suggests consciousness might be a universal property, like charge or spin, existing in some form in all matter. Not just in brains, not that rocks have thoughts, or that atoms daydream, but that the stuff of the universe contains a faint glimmer of proto-consciousness. A basic spark of awareness that, when arranged in complex systems like the human brain, flares into full self-reflective experience. It's a little like saying water has wetness, even when it's just individual molecules, not enough on their own, but essential when combined. From this view, consciousness isn't something added to the universe later. It's something that's always been there, unfolding in complexity, just like matter and energy. And some physicists go even further. The integrated information theory, proposed by neuroscientist Giulio Tononi, tries to quantify consciousness in terms of how much information a system integrates. The more integrated and irreducible the system's information, the more conscious it is. This turns the idea of consciousness as an accident into consciousness as a measure of complexity, a spectrum, not a switch. But perhaps the boldest idea of all comes from physicist John Wheeler, who once said, according to this view, reality is not made of stuff, but of answers to questions, bits of information like yes or no, on or off. And who asks the questions? Observers. In this view, consciousness doesn't just witness the universe, it gives it form by interacting with it. It doesn't mean the universe depends on humans, or that nothing exists without us. It means that conscious awareness might be part of the machinery that translates possibility into actuality. That without observation, the universe is like a book that hasn't been read yet. A script full of potential, but no performance. This isn't a mystical idea. It's rooted in the strange confirmed behaviors of quantum systems, where how you look affects what you see. In this sense, consciousness might be the universe looking at itself, a feedback loop where awareness isn't separate from reality, but woven through it, a thread of meaning running through every measurement, every decision, every moment. This doesn't mean that we can think things into existence, or that the universe is controlled by thoughts like magic. It means that at the deepest levels, reality and consciousness might be more intertwined than we thought. The more we study the brain, the more we realize that our experience of the world isn't direct, it's interpreted. And the more we study quantum physics, the more we realize that observation changes outcomes. Somewhere between these truths lies a possibility that the universe is not complete without awareness. That experience is not an accident, but a feature. And perhaps that the capacity to know is not just a result of the universe, but a reason for it. Imagine if beneath all the particles and forces and fields, what really mattered was the presence of knowing, of experience, of the quiet light that lets things be seen and felt. That would make consciousness not the end of the story, but its foundation. And maybe that's what makes you so astonishing. Not just your body or your thoughts, but your awareness of having them, that soft presence behind your eyes, the silent sense of being here. It doesn't shout, it doesn't weigh anything, but it changes everything. If consciousness is a fundamental force, then your attention, your curiosity, your wonder, they are not small things. They are not side effects. They are part of how the universe comes alive. And tonight, in this quiet space, with your thoughts gently drifting and your mind wrapped in soft science, maybe you can feel that presence more clearly. Not as something you own, but something you own, but something you are. A living point of awareness in a vast, mysterious field of being. Not the center of the universe, but its witness, its echo, its flame, and perhaps, just perhaps, its purpose. we could be living in the dying echo of another universe. Imagine walking through a forest and hearing a sound so soft and far away that you can't quite tell where it came from, but it lingers in the air, bouncing between the trees like a memory refusing to fade. And you begin to wonder, was it just the wind, or did something happen here long ago that you're only now noticing? Now stretch that thought beyond the Earth, beyond time, and ask, what if everything we see, the galaxies, the stars, the laws of physics themselves, are part of a cosmic echo from something that came before? What if this universe we live in is not the first, but the latest in a long line of universes, and we are moving through the fading vibration of one that ended before ours began? It might sound like the stuff of imagination, but some scientists believe this is more than a fantasy. It's a real possibility based on the strange and wonderful ways the cosmos behaves. They call it a cyclic universe, or a cosmic bounce, where the universe doesn't just begin and end, but breathes in and out, expanding and collapsing over and over across unimaginable stretches of time. And in this view, our entire existence, every tree, every person, every thought, could be blooming in the quiet aftermath of a universe that once lived, died, and left behind the seed of this one. To understand why anyone would think such a thing, we need to look at how our universe began, or at least, how we think it began. According to the Big Bang Theory, about 13.8 billion years ago, all of space, time, matter, and energy were packed into an incredibly hot and dense point. Then, in a flash, it began to expand, cooling as it grew, forming stars, galaxies, and eventually us. But here's the strange part. If the universe had a beginning, what came before it? For a long time, the answer was simply nothing. Time itself started with the Big Bang, so there was no before. But that idea feels uncomfortable, like a sentence without a subject. And physicists, being naturally curious, began to ask whether the Big Bang was truly the beginning, or just a transition. What if, instead of bursting out of nowhere, our universe emerged from the collapse of an earlier one, like a phoenix, rising from ashes, or a wave, forming from the splash of a previous one crashing down? This leads to the idea of cosmic rebirth, that every end contains the ingredients of a new beginning, and that the Big Bang might have been the echo of a cosmic Big Crunch that came before. There's even some math and physics behind this. In models called conformal cyclic cosmology, proposed by the famous mathematician Roger Penrose, the universe never really ends. It just transforms. According to his theory, as the universe expands and cools, matter decays, black holes evaporate, and time loses its meaning, because there's nothing left to measure change. Eventually, everything becomes so smooth and uniform that the universe resembles the conditions right before the Big Bang. And from this strange sameness, a new universe can emerge. Different from the last, but linked by deep patterns in space and time. In this picture, time is a loop, not a line. But it's not just Penrose. Other scientists explore different versions of this idea, from ek-pyrotic models, where universes arise from the collision of higher dimensional branes, to quantum bounce theories from loop quantum gravity, which suggest that when the universe collapses to a small point, quantum effects prevent it from hitting zero size, and instead cause it to bounce back into expansion. In all these models, the message is clear. What we call a beginning might just be a rebound from something else that ended. But if our universe is a recycled echo, could we find any trace of the previous one? Surprisingly, some researchers think so. Penrose and his colleagues even claim to have found hints in the cosmic microwave background, the faint afterglow of the Big Bang that fills the sky like invisible fog. They believe that tiny circular patterns in this radiation could be scars left behind by events in a previous universe. Specifically, the collision of supermassive black holes. While not everyone agrees, the idea is thrilling, that embedded in the quiet hum of the universe is a whisper from another cosmos, one that lived and died before we were born. And even if the evidence turns out to be mistaken, it opens the door to a deeper possibility, that our universe might be part of something far larger, and older than we imagined. A single breath in an endless rhythm of creation and collapse. This changes how we see everything, not just cosmology, but existence itself. Because, if the universe we live in is not the only one, and if we are rising from the quiet ashes of another, then everything becomes part of a greater story. A child looking at the stars might not just be gazing into space, but into the distant memory of another reality. Now gone, but not entirely forgotten. Every atom in your body might be made from the remnants of stars born in that previous cosmos, recycled and reshaped by new laws, new conditions, new time. You are, quite literally, made of echoes. And that doesn't make you any less real. It makes you more mysterious, like a song composed of notes from another melody. You carry within you the rhythm of something ancient, something unknowable, something that came before. And in this way, the universe is not just a place. It is a process, a story, a pulse. And we, for now, are its current heartbeat. So tonight, as your breath slows and your thoughts begin to drift, imagine the whole universe breathing with you. Imagine that beyond this moment, beyond this life, beyond this world, there may be other universes. Older, newer, stranger, stacked like pages in a book we can't yet read. And know that even if we never find clear evidence of the universe before ours, the idea itself is a kind of gift, a reminder that endings might not be final, and that everything we are could be the continuation of something unimaginably vast. Maybe you are not just a tiny part of the cosmos. Maybe you are a ripple in its memory, a moment in its cycle, a voice in its long, echoing song. And perhaps, just perhaps, the quiet around you now isn't empty. It's what remains when one universe exhales and another begins to dream. The universe is a giant brain, cosmic neurons in structure and function. What if the night sky isn't just a sea of stars, but the thinking face of the universe itself? Imagine lying back beneath the stars, staring up at the Milky Way, and wondering, not just how far it goes, or how old it is, but whether it might be alive in a way we don't yet understand. It's a strange thought, but not an empty one. Over the past few decades, some physicists and complexity theorists have noticed something deeply unsettling and fascinating: the structure of the universe. The way galaxies are spread out, connected, clustered, and organized bears a remarkable similarity to the structure of a brain. Not metaphorically, but mathematically. The pattern of neuron connections in the human cortex, when viewed from far away, isn't so different from the way galaxies form cosmic webs across the cosmos. The filaments, voids, and clusters that make up the large-scale structure of the universe map eerily well onto the networked pathways of brain tissue. This doesn't mean the universe is literally thinking like we do, but it opens a door to a mind-bending possibility that the universe might be processing information in some unknown way, and that we might be part of a much bigger system than we've ever imagined. Let's break this down. In your brain, there are around 86 billion neurons, and each one is connected to thousands of others, creating a vast web of communication that lets you think, feel, remember, and dream. When you imagine something or learn something new, tiny electrical signals zip across these networks. Your thoughts are physical patterns in a real electric storm of connection. Now scale this idea up. Across the observable universe, there are something like 2 trillion galaxies, many of which are linked together through vast invisible strands made of dark matter and gravity, forming a colossal web-like structure. These cosmic filaments stretch across hundreds of millions of light years and bind galaxy clusters together into a kind of neural mesh. Researchers have even compared simulations of both systems and found that despite being separated by an unthinkable difference in scale, the universe and the brain both show nearly identical patterns of information density, clustering, and connectivity. They aren't the same substance, but the pattern of organization is shockingly similar. And in science, when two things look alike, it's worth asking, could they also work alike? This isn't just poetic coincidence. In 2020, a team of astrophysicists and neuroscientists from Italy published a study comparing the brain's neuronal network with the cosmic web. They examined aspects like the number of connections per node, how efficiently signals can move across the system, and how well different parts of the network stay connected, even when random links are removed. The result: both systems appear to optimize for the same balance of efficiency and complexity. That means the universe, at least in structure, may be built to behave in some ways like a living brain. Of course, that doesn't mean it's conscious in the way you are. But if galaxies are like neurons, and gravity is like the communication between them, then the universe could be sharing and processing information on an immense scale, possibly in ways we can't yet measure or understand. Some researchers have gone further, asking whether space itself might be capable of computation. Just as your brain uses electrical impulses and chemical reactions to store and process data, the universe might use quantum interactions, gravitational waves, or the curvature of space-time as a kind of logic circuit, an alien, ancient, and incomprehensibly vast version of thinking. This might sound too wild to be science, but there are precedents. In the 1940s, Alan Turing and others showed that computation doesn't require silicon chips or wires. All you need is a system that can move from one state to another in a controlled way. A switch that can be on or off. That's it. A brain can do this. So can a computer. So can certain molecules. And in theory, so can the geometry of space-time. When particles interact, when waves interfere, when black holes spin, they might not just be physical phenomena. They might be performing steps in a kind of universal computation. That's what some physicists and philosophers have proposed. That reality itself might be a computational process, a constantly evolving flow of information. This leads to fascinating questions. If the universe processes information, what is it processing it for? Is it calculating its own future? Is it simulating possibilities? Or is it simply what existence does? Like breathing, like flowing, like becoming. And if consciousness arises from networks of information in our brains, could something even vaster emerge from the universe's networked web? This is where science brushes gently against philosophy, because even if the universe isn't thinking, in any way we would recognize, the resemblance between the cosmic web and the brain invites a deeper kind of reflection. Maybe it's not that the universe is a brain, but that brains are miniature universes. Maybe the patterns that allow thought, memory, and imagination to exist in you are the same patterns that built stars and galaxies. Maybe consciousness isn't something rare, but something that emerges naturally from complexity, wherever it arises. In that case, the universe doesn't need to be alive in the human sense to be profound. It only needs to be connected, and in a strange way, you are part of that. Your brain is made of atoms forged in stars. Your thoughts are the result of forces shaped by the universe's own evolution. And when you wonder about the cosmos, it's not just curiosity, it's the universe reflecting on itself through you. So the next time you look up and see the stars shimmering like neurons in a vast sky, remember, you might be more deeply connected to the universe than you were ever told. Not just made of it, not just floating inside it, but part of its pattern. You think, feel, remember, and wonder, just as the universe might, in its own strange and silent way. And whether or not it's conscious in the way we understand, maybe consciousness isn't something that exists in the universe, but something the universe does, something it expresses through stars, through cells, through you. And in that sense, every heartbeat is a kind of echo, an electric whisper from a thinking cosmos, still unfolding, still learning, still dreaming. The Earth might be inside a black hole. What if everything you've ever known, your body, your home, your planet, the stars, and even the whole universe, was already inside a black hole, and you just didn't know it? It sounds like science fiction, like something made up to scare or amuse. But this is a real question that serious physicists have asked. And the deeper you go into it, the less ridiculous it sounds. To understand why, let's start with the basics. A black hole forms when a massive amount of matter is packed so densely into a small space that it warps the fabric of space and time so severely, not even light can escape its pull. That boundary, the point where no return is possible, is called the event horizon. Inside it, all paths lead inward. But here's the twist. Some scientists think that the Big Bang, the moment our universe was born, could have actually happened inside such an event horizon. In other words, our entire universe, stretching out for billions of light years in all directions, might actually be the inside of a black hole that exists in some larger space we can't see. And once you hear the reasoning, it's hard not to wonder if it could be true. Let's go back to the beginning, not of your life or even of the Earth, but of everything. The universe is expanding. That's one of the most well-supported facts in cosmology. Galaxies are flying away from each other, not because they're moving through space, but because space itself is stretching. The farther away something is, the faster it seems to recede from us. Now imagine running this cosmic movie backward. Galaxies get closer, space contracts, temperatures rise, and everything rushes toward a single, hot, dense beginning, what we call the Big Bang. But here's something curious. The equations that describe black holes and the equations that describe expanding universes share more than a little resemblance. In both cases, time and space behave in extreme ways. In fact, if you reverse the flow of time inside a black hole, make it run outward instead of inward, you get something that looks an awful lot like an expanding universe. This has led some physicists to ask, what if the Big Bang wasn't the beginning of everything, but simply the emergence of a universe inside a black hole formed in some other, larger cosmos? It gets stranger. In a typical black hole, the singularity, the center where all the mass is thought to collapse, is a place where time and space break down. But some models suggest that instead of a singularity, a black hole could spawn a new region of space on the other side of its event horizon. This region wouldn't be inside the black hole as we imagine it, but rather a completely separate universe, cut off from the one that formed it. From the outside, you'd just see a black hole, dark, silent, heavy, but inside, there could be galaxies, stars, and even life, all unaware of what birthed them from this view. The Big Bang might not be an origin point at all, but a bounce, a transition, a doorway from one reality to another. And here's where it turns truly mind-bending. Our universe behaves as if it has an event horizon. There's a limit to how far we can see, beyond which light will never reach us. That boundary expands as time goes on, but it never lets us peek beyond it. In many ways, it acts just like the edge of a black hole, only from the inside. Now think about what it means to live inside a black hole. Not the kind where you get stretched into spaghetti by tidal forces, but a kind so massive, so stable, and so huge that the environment inside feels perfectly normal. Space would still stretch. Time would still pass. Atoms would still bond to make molecules, molecules to make cells, and cells to make creatures like you. You'd see stars. You'd feel gravity. You'd grow up, live your life, and never suspect that, from some broader vantage point in another dimension, your entire universe was hidden behind a dark veil, a black hole's event horizon. In fact, if you look at how our universe behaves, the expansion, the horizon, the uniformity of space, it matches what the inside of a black hole should look like under certain models of general relativity and quantum gravity. Some scientists argue it's more than a coincidence. It might be the answer to where our universe came from and where new ones might be forming right now. But if that's true, what does it say about everything we think we know? If our universe lives inside a black hole, then someone or something in another universe may have created the black hole that birthed us. That doesn't mean they did it on purpose. Black holes form naturally when stars collapse. But what if black holes are cosmic seeds? What if, every time one forms, It creates a new pocket of space-time with its own laws, its own constants, and its own future. That would mean black holes don't just destroy, they create. They become bridges, wombs, cradles of new existence. It's even been suggested in some speculative theories that universes might evolve in a kind of natural selection process. Universes that produce more black holes make more offspring over time. The multiverse favors those universes that are better at reproducing themselves. And maybe ours is one of them. Of course, all of this is deeply theoretical. We don't have a telescope powerful enough to see beyond our own horizon, nor can we peek into the heart of a real black hole to look for a tiny, swirling cosmos. But the math checks out in some models, and more importantly, it makes us ask questions we rarely think to ask. What is an origin, really? Does it mean first? Or does it just mean beginning from here? Is the universe a sealed story, or a single chapter in an infinite series of cosmic births and deaths? And if we're inside a black hole, then what we see as out there space, time, stars might actually be a kind of interior. We think we're on the outside looking in, but maybe we're on the inside looking out, mistaking the boundaries of our bubble for the edge of everything. In the end, the idea that Earth and everything else is inside a black hole might not be a final answer, but it's a powerful invitation to rethink what we mean by space, by time, by origin, and even by existence itself. Because if the universe is hiding inside something else, then we too might be more than we appear. Not just creatures crawling on a speck of rock, but living, breathing patterns inside a cosmic thought, held within a reality far larger than we could ever imagine. And that, in its own quiet way, is as beautiful and humbling as any truth science has ever dared to explore. Space might have consciousness, like properties at Planck scale. What if the tiniest bits of space, the parts so small that even our most powerful microscopes couldn't see them, were not just empty nothingness, but somehow aware, alert, maybe even quietly thinking in ways we don't yet understand? What if the universe itself wasn't built on dead, dull building blocks, but instead on specks of space that could respond, interact, maybe even know? This might sound like something from a fantasy book, but in the deep corners of modern physics, some scientists are starting to wonder whether the fabric of reality, space itself, might have consciousness, like properties when you zoom in far enough. And when we say far, we mean far beyond atoms, beyond electrons, beyond quarks. We're talking about the Planck scale, a level of measurement so small that a single grain of sand would contain more Planck units than there are stars in the entire observable universe. At this scale, space isn't smooth. It's not like a flat, quiet field. Instead, it behaves more like a stormy ocean, bubbling with energy and unpredictability, twisting and folding in ways we can't truly imagine. Some physicists describe it as quantum foam, a chaotic mess where the usual rules of time, distance, and even causality begin to blur. This is where the most basic parts of the universe live. Not particles, not waves, not even fields, just something. Something that pulses with possibility. Now, here's where it gets strange. If space is behaving like a dynamic, constantly fluctuating system at the tiniest level, if it isn't passive, but active, then maybe it's doing more than just holding everything. Maybe it is processing. Maybe it reacts to what flows through it. Maybe it stores a kind of memory. And maybe, just maybe, it contributes something we've always thought was exclusive to brains and living beings. Awareness, of course. No one is saying space is sitting there, writing poems or planning its day. That would be silly. But think about how your brain works. It's made of neurons, sure, but those neurons are just cells. Those cells are made of molecules. Those molecules are atoms, which are quantum particles, which are disturbances in fields that live in space. If you follow the chain far enough, everything your thoughts are made of, every feeling you've ever had, every choice, every fear, every smile, all of it arises from patterns in space. So why assume space is just a backdrop? Maybe it is the main actor. Some physicists believe the mind might not be something that appears only in brains, but something that could arise from information processing in systems of a certain complexity. And if the Planck scale structure of space is rich enough, if it processes information, interacts with itself, and evolves, then why couldn't consciousness be baked into the universe itself? Not human, like consciousness, but something more like proto-awareness, a basic ability to respond, to shape, to influence. This isn't just philosophical wonder. There are serious theories, like integrated information theory and panpsychism, that suggest consciousness might not be a special property of humans, but a fundamental aspect of the universe, just like mass or charge. It might emerge from patterns of causality and interaction wherever enough complexity exists. That means even a single electron might carry a whisper of experience. Even a floating photon might feel, in a way too simple for us to understand. At the Planck scale, space could be more than geometry. It might be the mind of the cosmos, fragmented and slow, but always humming. Now consider this. If the universe at its most basic level is conscious, what does that say about us? About trees? About stars? Maybe consciousness isn't a fluke. Maybe it's not something that accidentally evolved from slime and sunlight. Maybe it's what the universe wants to do. And this brings up even more fascinating possibilities. If the universe is built in awareness, even a simple one, it might explain things we usually wave away as mysteries. Why quantum particles choose outcomes when observed, why time moves forward, why order rises out of chaos. Perhaps the very fabric of space has a role in selecting, not just reflecting, the reality we experience. And if we ever learn to speak to that fabric, not with words, but with math and measurement, we might discover that we've been living inside a kind of dreaming lattice all along, a universe that doesn't just exist, but experiences itself through stars, through galaxies, through us, of course. Not everyone agrees. Many scientists still treat space as a neutral stage, something empty that only gets interesting when things are placed on it. But as we look closer, space doesn't behave like nothing. It curves, it warps, it vibrates with energy, it talks to mass, tells light where to go, stores fields, allows waves, creates boundaries. It might not be passive. It might be the source. And even if we never fully understand how or why, even the possibility invites a shift in how we live. It makes you ask, are you just made of the universe? Or is the universe alive in you? Is your consciousness just a byproduct of complexity? Or is it the latest flame in a fire that started long before time was born? It's humbling, it's beautiful, and maybe, just maybe, it's true. So tonight, as you fall asleep under the quiet whisper of stars, know this: beneath your thoughts, beneath your skin, beneath the particles of your bones, lies the same trembling foam of space that once birthed galaxies. And it may not be empty at all. It may be listening, it may be dreaming, and you, little by little, might be its way of waking up. The simulation hypothesis. What if reality is just code? What if the world you see around you, the sky, your hands, the stars above your house, the people you love, and even the thoughts running through your mind, wasn't the true base layer of existence, but something more like a very convincing illusion, like a dream you didn't realize you were dreaming? Or more radically, a simulation, an artificial reality running on some form of cosmic computer where everything that feels solid, every tree and planet and particle, is just lines of code running beneath the surface, quietly calculating your every breath, every memory, every coincidence that ever made you stop and wonder. It sounds like science fiction, and for years that's all it was. But today, real scientists and philosophers take this idea seriously enough to ask a question that sounds like a riddle wrapped in code. If you were living inside a simulation, how would you even know? And what would count as proof if even your senses could be simulated? Think about it. If you were born inside a perfect video game and had never seen anything else, would you ever question the walls around you, or would you simply accept the world as it was? Because it's all you've ever known. That's the uncomfortable idea behind the simulation hypothesis. That what we call reality may not be the ultimate flaw of the universe, but a cleverly built ceiling of appearances, just convincing enough that we stopped asking what's underneath. To really grasp this, you don't need to be a computer expert. You just need to understand a simple truth. Computers don't know what they're doing. They only follow instructions. Every image on your screen, every song you hear, every move your character makes in a game is made up of code. Zeros and ones that tell the machine what to display, when to blink, when to react. Now imagine a computer not just drawing pictures, but generating a whole world. Landscapes, weather, animals, rules of physics. That already exists. We call them simulations. Scientists run them to model everything from hurricanes to star formation. So here's the leap. What if our entire universe is just one incredibly sophisticated simulation? Billions of times more advanced than anything humans have made, but built on the same basic idea. Not to entertain us, but maybe to study us, or to explore different timelines, or perhaps even without purpose at all, just because some intelligence had the ability to run it. The idea might sound wild, but it's not as far-fetched as you'd think. Quantum mechanics, the science that governs particles, shows us that reality doesn't behave the way we thought. Particles pop in and out of existence. They don't have set properties until measured, and things far apart can influence each other instantly. As if the universe isn't physical at its root, but mathematical. As if it's being calculated, not simply existing. One of the most fascinating arguments comes from philosopher Nick Bostrom, who proposed that if any civilization advanced enough to run ancestor simulations, realistic virtual worlds to study their past, then it's likely they would run many of them, not just one. And if those simulations are indistinguishable from reality to the beings inside them, then statistically speaking, most conscious beings wouldn't be living in the one base reality, but in one of the countless simulations that includes you. It's a probability argument, not proof, but it hits like cold water to the face. Add to that some strange facts about our own universe, like how physical constants are finely tuned, how everything behaves according to mathematical rules, how we haven't found aliens even though we expect to, and you begin to see why some physicists are asking, could it all be code? Could the quantum fuzziness of particles, the strange behavior of time, and the limits of light be features of a simulated system, like frame rates and rendering distances in a video game? Even space might not be continuous. It might be pixelated, like the smallest unit of distance in the universe is a bit of space. Now, don't let your mind spiral just yet. This isn't saying that you're a puppet or that nothing matters. Quite the opposite. If anything, this idea forces us to take a deeper look at what consciousness is. If reality is a simulation, and you are aware of it, then your awareness is the most real thing there is. That's a strange thought, that the mind might be more fundamental than matter, that the observer, not just the observed, holds the key. Some scientists even think consciousness could be the final missing ingredient in physics. Not just a byproduct of the brain, but a necessary part of how the universe functions, how code becomes experience. And that ties directly into the simulation idea. After all, what's the one thing a simulation can't perfectly fake? The feeling of being aware, the you behind your eyes. So maybe your consciousness isn't just part of the simulation, it might be the bridge that reaches beyond it. Of course, we must be careful. There's no direct evidence for the simulation hypothesis. You won't pull back a curtain and find a motherboard. But the elegance of the laws of physics, the strange digital behaviors at the quantum level, and the eerie similarities between our universe and information systems make it a question worth asking. Could the Big Bang have been the moment the simulation started? Could black holes be storage points or processors? Could déjà vu, synchronicities, or the sense of glitches be hints at something deeper? These are not proven, but they are fascinating ways to look at old questions with new eyes. And in that sense, the simulation hypothesis isn't really about proving we live in a game. It's about realizing that reality may be far stranger than we assume. and that our place in it might be more fragile or more meaningful than we ever thought. So here you are, listening to this idea. Your neurons firing, your thoughts stretching, trying to grasp something invisible, code beneath the curtain of the cosmos. Whether or not we live in a simulation, we already act as though we do. We create digital worlds, avatars, algorithms, fake realities with real emotions. We build illusions that make people laugh, cry, love, and believe. Maybe we're the simulation builders of the future. Maybe we're just part of someone else's story. Or maybe this entire question is a mirror, one that reflects not the outside world, but the depth of our own curiosity. Because when we ask if reality is code, what we're really asking is, what does it mean to be real? And maybe the answer doesn't lie in bits or atoms, but in wonder itself, the quiet, persistent, childlike urge to keep looking, keep asking, and never stop questioning the world, even when it feels complete, because sometimes it's the questions without answers that carry us closest to the truth. There might be more than 3 dimensions of time. What if the ticking of the clock, the sunrise and sunset, the way your memories line up in order like beads on a string, all of it is only a thin slice of something much bigger, much stranger, and quietly hidden behind the curtain of what we call normal. We grow up believing that time flows in a single straight line, like a river that moves from the past, through the present into the future. And we treat this as if it is the one and only way that time can work. But what if that's just the way our brains are wired to see it? And reality itself is more like a vast ocean of possible timelines, bending and branching and curling around each other in directions we can't even imagine, not because it's impossible, but because we're only seeing a shadow of what time truly is. Most of us are taught that we live in 3 dimensions of space, left, right, up, down, forward, backward, and one of time ticking forward, second by second. But some physicists and mathematicians have quietly started wondering, what if there's not just 1 dimension of time? What if there are 2, or even more? And what if our entire understanding of motion, cause and effect, choice, memory, and even free will is based on a very limited view of something infinitely more complex? To understand this without needing a doctor of philosophy, let's start simple. Imagine you live in a 2-dimensional world, like a drawing on a piece of paper. You'd know how to move left and right, maybe forward and backward. But up would be impossible to understand, because your world has no concept of that third direction. Now flip that idea. We are like drawings in time, aware of one way it flows, one way we move through it, but unaware of the upward dimensions that time might have beyond our grasp. Some theories suggest that if you could see those other time directions, events might no longer be locked in place. Things that seem unchangeable could become flexible. Effects might not always follow causes, or there could be timelines that run parallel, independent, or even perpendicular to our own, untouched by what we think of as past or future. It sounds wild, but in advanced physics, especially string theory and certain models of quantum gravity, extra dimensions of space and time are not just possible, they're necessary to make the math work. We usually hear about extra spatial dimensions, curled up too tiny to notice. But what if time also curls? What if time can loop, spiral, or crisscross itself in ways that let particles, or perhaps even consciousness, move through it differently? One idea, known as two-time physics, suggests that our universe might actually operate with 2 time dimensions underneath the surface. Even though we only experience one, this second time might not behave the same way. It might not flow like ours does. Or it might be more like a hidden parameter that controls deeper properties of reality, like a backstage control room shaping the stage. In some models, having multiple time dimensions helps unify the forces of nature in ways we can't otherwise do. It helps solve problems in physics that have baffled scientists for decades. But there's a catch. Adding time dimensions gets messy. More time means more possibilities, but also more instability. Things can go wrong fast if events are no longer chained together in one direction. Still, it raises breathtaking questions. Could our minds already be touching these extra dimensions when we dream, or when we feel like time slows down or speeds up? Are our intuitions about destiny, déjà vu, or parallel lives whispers from higher time? And could this be why quantum particles seem to decide how to behave only when observed? Because they're not just operating in our time stream, but across others we cannot see. Even stranger, some scientists and philosophers wonder whether time isn't a dimension at all, but an emergent illusion, something that only appears because of how our brains process change. What if all moments, past, present, and future, exist at once, like pages in a book, and we're just flipping through them one by one, giving us the illusion of flow? But in a higher dimension of time, perhaps someone, or something, could read all the pages at once. This idea echoes a concept in physics called the block universe, where time is a frozen structure, and what we call now is just a spotlight moving across it. But if there are multiple time dimensions, maybe there are multiple spotlights, maybe multiple nows, maybe we exist in more than one timeline, not metaphorically, but physically, split across temporal directions, like a prism splits light. Could this explain the strange sense that sometimes life gives us choices we feel we've already lived? Or the eerie feeling that time loops back, not just in dreams, but in the structure of thought itself? Of course, these ideas are still highly theoretical, and most of them remain untested. But they open the door to thinking about time not as a straight hallway we walk through, but as a giant cathedral with winding staircases, hidden balconies, echoing chambers, and secret doors. If there are multiple time dimensions, maybe we've only been living in the foyer, and that's what makes this topic so quietly thrilling. It's not just about physics, it's about freedom. Because if time is bigger than we think, then perhaps so are we. Perhaps your past isn't fixed, your future isn't written, and the version of you that feels stuck is just a temporary pattern in one slice of a much larger, multi-layered song. And maybe, just maybe, in some other dimension of time, you've already become everything you dream of being. You just haven't turned the page yet. So the next time you check the clock, or feel time racing or dragging, remember, it might not be a river at all. It might be an ocean with hidden currents, or a labyrinth with dimensions we haven't mapped. And maybe every heartbeat, every choice, every thought is not just something passing, but something echoing across deeper timelines waiting to be heard. After all, what is time, really, if not the soft music behind everything we do? And what might we discover if we dared to listen just a little more closely? Reality might be a compromise between observer and observed. What if everything you've ever seen, heard, touched, or believed wasn't entirely out there or entirely in here, but was instead the quiet handshake between your mind and the world? A shared creation that only becomes real when you look at it just so. Imagine for a moment that reality is not a movie playing on a screen while you sit in the audience, watching from afar, but more like a storybook you write and read at the same time, with every glance and every question turning the page in a direction that didn't even exist until you looked. This isn't just a poetic metaphor. It's a genuine scientific mystery with roots in quantum physics, psychology, and philosophy. At the heart of this strange idea lies a simple but astonishing question. What if the universe isn't fully real until something or someone observes it? And not just observes it like a camera records a scene, but interacts with it in a way that pulls its potential into a specific form, choosing one reality among many possibilities. Could the world you see be only one possible version, selected not just by chance or physics, but by the very act of you paying attention? This strange possibility lives inside one of the most famous puzzles in all of science, the double-slit experiment. When particles like electrons are sent through two slits, they behave like waves, creating interference patterns that suggest each particle travels through both slits at once, as if it can explore all possibilities. But the moment you try to watch which slit it goes through, just observe it, it collapses into acting like a particle again, choosing one path. The act of looking changes what it does. The observer changes the observed. And this isn't just a glitch in the experiment. This happens every time. It's as if reality plays by different rules when you're not looking. Rules that allow it to be fuzzy, multiple, undefined. But the second you peek behind the curtain, it tightens into something solid, definite, and specific. But here's the twist. This doesn't mean you create reality from scratch, like a painter with a blank canvas. It means something far more curious. Reality might be a negotiation between what's possible and what's perceived, between the external world and the internal witness. It might be a relationship. Think about your eyes for a second. They don't just receive light, they actively select, filter, and interpret it. You never really see the world as it is. You see what your brain thinks is most important, shaped by your expectations, memories, and focus. Two people can look at the same thing and notice entirely different details, because their minds are framing the scene in different ways. And in quantum physics, something very similar may be happening. Some interpretations suggest that particles don't have defined properties, like position or momentum, until they're measured. In other words, they aren't just waiting quietly with their attributes hidden. They don't have those properties at all until something, maybe you, maybe an instrument, asks the right question. The answer you get depends on how you ask. It's like a conversation where the world answers not with facts, but with possibilities collapsing into choices. And if this is true, then you've never been just a passive observer. You've always been a co-author of your own experience. This idea isn't limited to physics. In neuroscience, perception is also shaped by your expectations. Your brain doesn't wait for all the information to arrive. It guesses, anticipates, and then corrects. What you see, or hear, or feel might be partly real and partly predicted. Reality is assembled on the fly, built out of fragments and assumptions, constantly tuned by feedback loops between your senses and your expectations. Even your memories, the ones you feel sure of, aren't perfect recordings. They change subtly each time you remember them, like a story retold with small edits. So if your inner world shapes how you perceive the outer one, and if the outer world only solidifies when it is perceived, then maybe the boundary between subjective and objective isn't as sharp as we once thought. Maybe reality is neither fully external nor fully internal, but a bridge between both, meeting in the middle where attention touches existence. And this leads to a quietly thrilling thought. What if your very presence in the world changes the world? Not in a magical, wishful way, but in a structural one. The fact that you ask questions, make choices, and pay attention might be what sculpts the flow of your experience from a sea of potential reality. Might be not a fixed sculpture, but a living performance, where both the actor and the audience shape the story together. In this view, the universe isn't a rigid machine ticking forward on its own. It's a symphony that responds to its listener. And you, simply by being here, listening and wondering, might be playing a subtle but essential role in tuning the next note. So next time you look at something, your hand, a cloud, a star, a stranger's eyes, remember that what you see is only half the story. The other half is what you bring to it. Your attention, your curiosity, your questions. You are not just a passenger in this universe. You are part of its unfolding, and perhaps, just perhaps, the universe is watching you too, not as a judge or a god, but as a dance partner, responding to the rhythm of your gaze, waiting to become real in the space between seeing and being seen. The Mandela effect, a glitch in collective memory, or a quantum artifact. Have you ever been absolutely sure something was a certain way, only to find out, to your complete confusion, that it wasn't? That a famous logo you remembered had changed, or that a beloved childhood line from a movie was suddenly different? That's not just forgetfulness. It's something far stranger. It is called the Mandela effect. And it might just be one of the weirdest tricks your brain, or maybe the universe, is playing, named after the odd but surprisingly common memory some people had of Nelson Mandela dying in prison in the 1980s, when in fact he was released and later became president of South Africa. This effect describes a situation where large groups of people remember the exact same thing wrong. And we're not talking about hazy guesses or minor slips. These are vivid, detailed memories, whole phrases, spellings, images, even life events that never actually happened. Not in this timeline, not in this reality. The odd part. Everyone who remembers them is so sure that the Monopoly Man had a monocle, sure that Pikachu had a black-tipped tail, sure that it was Luke, I am your father. But all of these are wrong, and always have been. Or have they? This is where things get strange, because while memory errors happen all the time, the Mandela effect seems different. It's not just one person misremembering, it's often millions of people recalling the exact same incorrect thing. That's what gives it power. Not just the confusion, but the scale. The effect has grown to include countless examples. The Berenstain Bears versus Berenstain Bears. Mirror Mirror, on the wall versus Magic Mirror. Kit. Cat with a dash or not. Fruit of the loom with a cornucopia, or without. You can laugh it off as people just being mistaken, and many scientists do. But why do so many people remember the same wrong version? Why are some of these memories so clear, so emotionally charged, as if they really happened? Could it be something more than just misfiring neurons? Could it be that our reality isn't as stable as we think? One idea is that our memories are more like stories we rewrite every time we remember them, less like files stored in a folder, more like sandcastles rebuilt each time the tide rolls in. Psychology backs this up. Memory is reconstructive, not reproductive. That means you don't replay events. You rebuild them from scraps. The brain fills in gaps, adds details, smooths edges, even changes meaning based on new information or emotion. It's efficient, but it's not perfect. So it's entirely possible that the Mandela effect is just the result of collective reconstruction gone wrong. Social suggestion, internet spread, and pop culture confusion reinforcing shared false memories. And yet, that answer, while logical, still leaves something unsettling. Why do these errors follow certain patterns? Why do they cluster around specific pop culture items or historical moments? And why do they feel so real? That's where the wilder ideas begin to surface. One theory, straight from the edges of quantum physics and speculative science, is that the Mandela effect could be evidence of parallel realities. That somehow we're slipping between slightly different versions of the universe without realizing it. Imagine infinite timelines, all coexisting, each one slightly different. In one, Nelson Mandela died in prison. In another, he lived. In one, the Monopoly Man wears a monocle. In another, he doesn't. And maybe, just maybe, our minds occasionally retain fragments from the wrong version. The version we were in before, something shifted. Maybe the universe merged two timelines. Or maybe you moved from one to another in your sleep. Your dreams, your choices. It sounds fantastical. But then again, quantum physics already tells us that particles can exist in multiple states at once, that outcomes depend on observation, and that reality might not be as fixed as we think. If the universe is a multiverse, and you can move from one timeline to another without knowing, then the Mandela effect could be the residue. The leftover memory of a version of reality you no longer live in. Even some physicists entertain the possibility that our perception of reality is shaped by more than what we can observe. The many worlds interpretation of quantum mechanics suggests that every possible outcome of every quantum event actually happens in a separate branching universe. So the decision to turn left or right, the particle going here or there, all split off into different versions of existence. What if the Mandela effect is simply our awareness catching a glimpse of one of those alternate versions? What if memory is the one part of us that can sometimes drift across the boundaries of these branching paths? It wouldn't be proof of parallel worlds, but it might be a hint. And there's another layer. What if it's not the universe that's shifting, but you, your perception, your role as observer? Maybe each mind interacts with reality in a way that helps construct it. This idea, touched on in interpretations of quantum theory, suggests that the observer isn't just watching the world unfold, but is helping choose which version unfolds. Your choices, your focus, your consciousness, these might not just affect your future, but the version of the past you remember. What if reality is participatory? What if memory isn't about storing the past, but negotiating with it? That could mean that the Mandela effect isn't a glitch, but a signal. A sign that your experience of time, of history, of what happened is fluid. That truth and memory aren't always synchronized. And that's not a mistake, but part of the mystery. Still, the simplest answer may be the most human one. We remember things together, not alone. Our memories are shaped by the stories we hear, the images we see, the people we trust. When millions of people share the same false memory, it doesn't necessarily mean the timeline broke. It could just mean we're all listening to the same background noise. But maybe, just maybe, every so often, something deeper breaks through. An echo from another version of reality, a whisper from a path not taken, a detail left behind when the story changed ever so slightly. Maybe the Mandela effect is the cosmic version of déjà vu, a flicker that says, this isn't how it was supposed to be, or is it? So the next time you find yourself certain about something, an old cartoon, a childhood phrase, the way history unfolded, pause, ask yourself, is this memory mine alone? Or does it echo across minds? Is it a simple mistake? A psychological trick? Or could it be something more? A reminder that even the past might not be as fixed as we thought, and that your mind may be more connected to the structure of reality than you've ever dared to imagine. Whether it's a collective illusion or a quantum breadcrumb trail, the Mandela effect invites you to question not just what you remember, but why you remember it. And in that questioning, perhaps, lies the true mystery worth exploring. The universe might be recycled, endless Big Bang and Big Crunch cycles. What if the universe doesn't end with a bang or a whisper, but simply begins again? Over and over, like a breath, drawn in and slowly let out, only to be taken in once more. Imagine that everything you've ever known, every star, every atom, every memory, every mistake, is not part of a one-time cosmic event, but a single chapter in a story that's told again and again through time beyond time. The idea isn't new, but it's powerful that the universe might be recycled, that after expanding outward from the Big Bang, it could someday slow down, reverse, and collapse inward in a great cosmic contraction, a big crunch, that squeezes all of existence back into an unimaginably dense, hot, tiny point, only to explode outward once more in a brand new Big Bang, starting it all again. Scientists call this the cyclic or oscillating universe model. And while it sounds like science fiction, it's rooted in real questions about the nature of time, energy, and entropy. You see, the Big Bang isn't just a theory. It's the best explanation we have for how space and time, matter and light, all began around 13.8 billion years ago. But if it had a beginning, does it need an end? And what kind of end would that be? Our universe is expanding. That's something we've observed directly. Galaxies are drifting away from us. Not because we're at the center of anything, but because space itself is stretching, growing between everything. For decades, physicists wondered if this expansion would continue forever, or whether gravity, slow, patient, and constant, might one day pull everything back together. It's not impossible. After all, gravity has no off switch. It pulls at everything, quietly, universally. And if the universe contains just enough matter, just enough mass and energy, then that gravity might eventually stop the expansion. It would be like throwing a ball into the air. At first it rises, then it slows, then it stops, then it falls. In this view, the universe is that ball. The Big Bang was the throw. We're in the rising phase, but maybe one day it will fall. It will contract. Galaxies will begin to inch closer instead of further. Stars will collide more often. Heat will rise. Space will shrink. Time might warp and loop, and in some unknowable future, trillions upon trillions of years from now, it could all fold back into a singularity. The beginning pressed into the end, waiting once more to ignite. Then another Big Bang, another unfolding, another version of everything, not a replay, but a new draft of the cosmos. Some physicists have even tried to calculate the conditions for this. They look at the universe's total energy. They examine dark matter, dark energy, cosmic background radiation, and entropy, the gradual spreading and thinning of usable energy. And entropy might be the key to why the universe would recycle. Because if entropy always increases, then perhaps each cycle builds complexity. Or perhaps it forgets more and more each time, fading into simplicity. Some models even suggest that time itself could flip inside these contractions, that the future becomes the past, and the past becomes the seed of something new. In these theories, time isn't a straight line. It's not even a loop. It's like a breathing rhythm, an inhale and exhale of everything that exists. There's also the concept of a bounce. The big bounce, they call it. Not a crunch that ends all things, but a turning point. Imagine the universe as a trampoline stretched under a weight. As it stretches, tension grows, and at a certain point it snaps back, not destructively, but rebounding into something else. The fabric of space and time might do something similar. And you, yes, you might have existed in other cycles, not as you are now, but as some rearrangement of particles and energy, some whisper in the background hum of existence. Maybe your consciousness is just one pattern the universe stumbles upon again and again in its infinite dance. Or maybe not. Maybe this cycle will be the last, or the first. Or maybe cycles don't repeat, but echo, like ripples from a stone thrown into a pond that slowly fade. Never quite the same, never quite gone. It's also possible the universe won't crunch at all. Maybe it will keep expanding forever. Maybe dark energy, this mysterious force pushing galaxies apart, will only grow stronger, and space will stretch into emptiness so thin that even atoms drift apart. But that's another story. For now, the idea that the universe might breathe, that it might begin again after every ending, is a comforting thought to some. It means no story is truly over, no moment is truly lost. Even in cosmic terms, there is rebirth. Not reincarnation in the spiritual sense, but in the physical, mathematical structure of reality itself. Maybe the stars you see now were born from the ashes of a universe that came before this one. Maybe black holes are seeds, not graves. Maybe every question we ask echoes across cycles. We'll never remember, but always continue. And in the quiet rhythm of that breath, in, out, expansion, contraction, silence, explosion, you can almost feel that the universe isn't rushing anywhere. It's taking its time, starting again when it needs to. Never in a hurry, always in awe of its own becoming. So tonight, as you rest under a sky filled with ancient starlight, know this: even if everything you know fades away one day, even if all is lost to heat, gravity, and time somewhere, somehow, the universe may begin again. And that's a story worth dreaming about. Some UFOs might be interdimensional, not interstellar. You've probably heard the idea that UFOs, those strange lights in the sky, the flying objects that move in ways our jets and drones can't, might come from distant planets, built by aliens with incredible technology, who cross the ocean of space to visit Earth. But what if that assumption is completely wrong? And instead of coming from far away, they come from somewhere else entirely, not across space, but across dimensions, slices of reality layered over ours, that we can't normally see, like invisible pages. In a cosmic book we're trapped inside without realizing there are chapters we've never read or even imagined. To understand why some scientists and thinkers believe this, You first need to know what a dimension is. Not just height, width, and depth, but the idea that reality might have extra directions, invisible to us, where other kinds of matter, light, and even life could exist, not millions of miles away, but right here, just offset. Imagine you're a cartoon drawn on a sheet of paper. You live in 2 dimensions, able to go forward and sideways, but never up. And then, one day, a finger pokes through your world from above. You wouldn't see the whole hand, just a strange circle that appears and vanishes, leaving you puzzled. That's the kind of experience some people think we might be having with UFOs, not visitors from space, but glimpses of things slipping into our 3D world from higher dimensions, and then slipping back out again before we can understand what they were. This might sound wild, but it is rooted in real scientific ideas, especially in theories like string theory and M theory, which suggests that the universe may have more than just the 3 dimensions we move through, and the one we call time. Some of these extra dimensions could be curled up or hidden, and we wouldn't notice them in daily life, just like you don't feel the Earth spinning, even though it's always turning. But if advanced civilizations had access to these higher dimensions, if they had somehow figured out how to navigate or open doors between layers of reality, they wouldn't need to travel light years across the galaxy. They could take a shortcut, like stepping from one room into another through a secret passage that we don't even know exists. From our perspective, a UFO might appear suddenly, dart through the sky with impossible speed, and vanish without a trace. Not because it's faster than light, but because it's slipping between worlds that don't quite align. And if this idea seems too abstract, remember that even in our own physics, particles can do strange things. In quantum mechanics, particles can be in multiple places at once, and teleport across space in ways that defy everyday logic. The universe already allows for behaviors that seem interdimensional, so maybe the jump from possible to real isn't as far as we think. Now let's look at why some people lean toward the interdimensional hypothesis. Over decades, radar operators, pilots, astronauts, and military personnel have reported objects that break the rules of our known physics, moving with sudden acceleration, stopping mid-air, turning at angles that should crush anything inside. If they were from space, they'd still be limited by inertia, by energy, by Newton's laws. But if they're not bound by our dimension, if they're using some physics we haven't discovered, they might not be playing by our rules. They wouldn't have to. Imagine watching fish in a pond. You're not bound by the water. You can appear above them, touch the surface, even dive in for a moment. But to the fish, your finger might seem like a mysterious object that enters their world and vanishes without explanation. Could UFOs be the same? Brief intrusions from a reality that lies just beyond the surface of ours, noticed only when they choose or when something slips through by accident. Interestingly, this idea also explains why we never find physical traces. No crashed ships, no alien tools. If the objects aren't native to our reality, they might not leave behind debris we can detect, or they might not be objects at all in the way we understand them. Just like shadows or reflections, they might be projections, manifestations of something whose true form we could never see unless we somehow stepped into their dimension. This might also explain some of the eerier parts of UFO reports. Why witnesses describe time slowing down, silence falling, strange feelings in the air. These could be side effects of interacting with another dimension, like walking near a magnet and feeling its pull without touching it. We know our senses are limited. We see only a sliver of light, hear only a narrow band of sound. If there are forms of perception beyond ours, it would make sense that interdimensional phenomena would be partially invisible, partially incomprehensible, like colors you can't see but somehow feel. Even modern science gives us clues that our reality might be part of something deeper. In quantum entanglement, two particles separated by great distances can instantly affect each other, as if connected by a thread outside of space. In holographic theories of the universe, All of reality might be a projection from a higher dimensional space. If these ideas are even partially true, then interacting with other dimensions might not require spaceships or advanced hardware. It might require tuning into something we don't yet understand, or maybe even something that understands us. Some speculate that consciousness itself, your awareness, your thoughts, could be the bridge. If reality has layers, then perhaps what we call mind isn't just a product of the brain, but something that touches other levels of being. And if intelligence can span dimensions, then maybe we're being observed not from afar, but from within, from a reality parallel to ours, whispering across the veil. Of course, none of this means we should jump to conclusions. Most UFO sightings have earthly explanations: weather balloons, drones, reflections. The interdimensional hypothesis doesn't claim that every strange light is from another world, but it gives us a framework to ask deeper questions about what reality is, how much of it we can sense, and whether we're alone not just in space, but in existence. It's not about aliens with green skin or metallic spaceships. It's about the possibility that our reality might not be all there is. That just beyond the edges of what we can measure, there are structures, beings, or phenomena that don't follow our rules, because they were never part of our world to begin with. And maybe that's the most beautiful idea of all. Not that we're being visited, but that we're part of a larger fabric of reality, one filled with unseen dimensions, quiet watchers, and strange wonders that occasionally brush against our lives and remind us that we don't have all the answers. Maybe it's not about evidence. Maybe it's about humility, about keeping our minds open, not to fantasy, but to possibility. Because in the quiet spaces between what we know and what we believe, there might be doors we haven't even imagined yet. And maybe, just maybe, some of them open from the other side. Dark matter could be a shadow version of our own universe. Have you ever had the feeling that something is there, even when you can't see it, can't touch it, and can't prove it with your eyes? But everything around you seems to respond to it anyway, as if reality itself is bending around something invisible. That's exactly how scientists feel about something called dark matter. A strange, unseen stuff that seems to make up most of the universe's mass, but has never been directly observed, never been caught in a lab, and never once glowed, reflected, or interacted with light. It's like there's a ghost running the universe, and all we can see is what it moves, not the ghost itself. And here's where things get really strange. What if that ghost isn't just invisible matter hiding between galaxies, but an entire shadow universe, mirroring ours, right next to us, overlapping us, sharing the same space, but in a way we can never quite touch? That's not just poetic, it's a real possibility that physicists are starting to take seriously. Because everything we've ever seen, every planet, star, galaxy, dust cloud, atom, and photon, makes up only about 5% of the universe. The rest, around 27%, is dark matter, and another 68% is dark energy, both completely invisible. And if dark matter was just a simple mystery, we might expect it to clump like normal stuff. But it doesn't. It moves differently. It pulls galaxies together without ever glowing, passing through ordinary matter like a shadow through fog. So some scientists have begun to ask, what if dark matter isn't just matter we can't see, but matter that's different? Matter that lives in its own hidden version of physics, its own secret set of rules. In other words, a parallel universe, made not of imagination, but of real particles, real forces, real complexity, just hidden in a way that only gravity can reveal. Imagine a version of our universe, where everything looks like it does here. Galaxies spinning, stars exploding, maybe even life existing. But it's built from particles that don't talk to ours. Their light doesn't shine into our world. Their atoms don't bump into ours. But their gravity still works. It's like living in one apartment of a huge building, unaware that there's someone quietly walking above you, moving furniture, causing the ceiling to creak. But you'll never meet, never speak, never share a meal. That's one of the current leading ideas. The mirror universe hypothesis, that dark matter could be ordinary matter in a shadow world, one that split off from ours early in the Big Bang, evolving under its own hidden physics. And it's not as far-fetched as it sounds. In fact, if you look at the math of how particles interact, there's a strange kind of symmetry that keeps showing up. Mirror images, flipped charges, backward spins. Every particle we know has an antiparticle. Every force we observe has an opposite. But what if that symmetry doesn't stop at particles? What if it extends to whole realms, entire universes, where the laws of physics echo ours, but slightly shifted? This could explain why we can't find dark matter. It doesn't shine, not because it's missing something, but because it's following its own version of electromagnetism, one we can't feel. Maybe its photons are dark to us. Maybe its electrons don't click with ours. Maybe their chemistry is like ours, but always behind a curtain. Some versions of this idea even suggest that shadow life could evolve there. Beings made of dark atoms, orbiting dark stars, living on dark planets, watching their own sky with their own telescopes, wondering what invisible force is pulling on them from beyond. And guess what? That invisible force might be us. That's the beauty and the strangeness of this idea. If both our universe and the shadow one exert gravity, then we're not just feeling them. They're feeling us too. We are ghosts in their sky. We are their dark matter. It's a cosmic two-way mirror. But why would the universe split like that? Well, during the Big Bang, things weren't smooth and tidy. Energy was chaotic, temperatures extreme, and the tiniest fluctuations in symmetry could have caused whole sectors of reality to follow different rules. One pocket might become our universe, full of atoms and stars and visible light. Another might become the shadow sector, full of particles that never learn to glow for us, but still obey their own version of gravity, inertia, even structure. It's like baking two cakes in the same oven, side by side. Same ingredients, slightly different recipes, and completely separate flavors. Now here's something even more fascinating. Physicists are designing experiments to test whether these hidden sectors exist. Some are looking for tiny bumps in cosmic radiation, ripples left over from when these universes might have jostled each other long ago. Others are building detectors to catch portal particles that might briefly blink between our world and the shadow one. These particles wouldn't behave like anything we know. They'd be here one moment, gone the next. Not because they disappeared, but because they went elsewhere. There's even a concept called a dark photon, a cousin of our photon, carrying force in the shadow realm, hinting at a whole network of unseen light. And it's not all science fiction. These ideas are grounded in real equations, real patterns, real missing mass. We didn't invent dark matter to tell stories. We invented it because galaxies spin too fast. Stars move as if held by invisible glue. Without dark matter, everything would fly apart. So we know it's there. We just don't know what it is. But maybe it is them. Now pause for a moment and think about what that means. If there really is a shadow universe, if we're brushing elbows with it through gravity, orbiting its invisible stars, feeling its tug in our tides and our galaxies, then we're not alone, even in the most silent corners of the cosmos. There may be a parallel version of physics, of reality, coexisting with us at every moment. We might never see it, we might never hear it, but we are dancing with it. Step for step, pull for pull. And perhaps the most beautiful part is this: even if we never meet the mirror world, we are already connected. Not through language, not through light, but through the most universal force of all, gravity. It doesn't care what kind of matter you are. It doesn't care if you're dark or light. It just links you like a silent handshake between realities. So next time you look at the stars, remember this: most of what holds the universe together is invisible. And that invisibility might not be emptiness. It might be another world, living its own story, hidden in the folds of our own. there might be infinite versions of you living different lives. Have you ever wondered what would have happened if you had said yes instead of no, turned left instead of right, spoken up instead of staying quiet, or smiled back instead of walking away? That tiny thought. The question of what could have been isn't just something humans feel when we're lost in memory or daydream. It might actually be real, because according to some of the strangest, most fascinating ideas in modern science, every choice you've ever made, and even the ones you didn't, might have created a new version of you. And not just one or two, but infinitely many yous, each living a slightly or wildly different life. Imagine this, right now, as you sit listening to these words. There could be another version of you who never clicked this video, one who did but fell asleep halfway, one who grew up in a different country, one who took a different job, one who didn't have a sibling, one who never lost that person you loved. It's not just fantasy, it's based on a theory from quantum physics called the many worlds interpretation, which says that every time something could happen in more than one way, both things happen, just not in the same universe. Instead of choosing one path, the universe splits, branching into two different realities, each containing a version of you who experienced a different outcome. It's like reality is not one straight line, but a giant cosmic tree, and you are the traveler whose journey splits again and again at every fork, creating an endless forest of parallel yous. Some nearly identical, others unrecognizably different. To understand how this works, let's go very, very small, smaller than atoms, smaller than protons, all the way down to quantum particles, the building blocks of everything. When scientists study these particles, they find something strange. Before you measure them, they don't seem to be in one place or state. They exist in all possibilities at once, a weird in-between condition called superposition. But the moment you observe them, boom, one outcome is selected, or so we thought. In 1957, a physicist named Hugh Everett proposed something radical. What if all those other outcomes still exist, just in different worlds? What if the universe doesn't choose a path, it just follows all of them? So when a particle goes left and right at the same time, it doesn't just collapse into one, two universes split, one for each path. If this is true, then you are doing everything you might ever do somewhere. You are both brave and afraid, successful and struggling, kind and cruel, healthy and sick, alive and not. You are a symphony of selves, spread across a multiverse of infinite possibility. And the implications are both comforting and haunting, because it means that you are not limited to this version of you, that the person you could have been is real, just not here. Let's go deeper. Every decision you've ever made, even the tiniest ones, like blinking or looking up or turning down a different street, creates a fork in this endless quantum branching. And while you go one way, another you goes the other. The you who studied art instead of engineering. The you who called instead of stayed silent. The you who said, "I love you," just in time. These aren't ghosts or stories, if many worlds is correct. They are just as real as this you. You'll never meet them, but you might feel them, in those moments where life feels strange, where you sense something missing, or when you dream of a life that never happened. Those feelings might not just be imagination. They might be echoes, soft ripples through the cosmic branches. Now you might ask, but if all those other me's exist, why don't I remember them? Because consciousness as we understand it is tied to this specific thread. You are like a flashlight shining along a single path of the multiverse. You can't light up every branch at once, but that doesn't mean the other branches aren't there. They're just out of your sight, but maybe not out of your reach forever. Now imagine how deep this really goes. In some versions, your life is very similar to this one. You had cereal instead of toast. You wore blue instead of red. But in others, entire world histories changed. Maybe the asteroid missed the dinosaurs. Maybe humanity evolved differently. Maybe Earth never formed. There are versions of you where you live in a world with flying cities, or one where electricity was never discovered. There are versions where your parents never met, versions where you were never born, but someone very much like you was. The possibilities are infinite, and the math supports it. According to quantum mechanics, there's no rule that says only one world is real. In fact, the equations seem to work better if all of them are. But this brings up a big question. If all these versions of you are out there, does it mean this version, you right now, is less special? Not at all. Because even if there are infinite yous, none of them are this you. Only you have lived your version of this story, your exact steps, your thoughts, your regrets, your loves, your lessons. You are one precious thread in the tap, and knowing that there may be others only makes yours shine brighter, not duller. But here's something even more mind-bending. Some scientists wonder if we could ever communicate across these branches. If the separation between worlds is absolute, or if there are quantum echoes that leak through. There are experiments in physics, like quantum computing and interference, that hint at the possibility that what happens in one branch affects others. Could intuition be a whisper from a parallel self? Could déjà vu be a glitch where your mind slips sideways, touching a memory from a life you didn't live? Could dreams be soft collisions between realities? These are not yet proven, but they are explored, because the deeper we dig into reality, the more it stops behaving like a simple machine, and starts acting more like an infinite storybook, where every page tells a different life. And what about free will? If everything that can happen does happen somewhere, then does that mean your choices don't matter? Every decision you make spins off a new branch, a new world, a new you. You are not one person making one choice. You are the engine that generates infinity. That's a power far greater than control. It's creation. You are the author of an entire multiverse, writing a new page with every breath. And even though you will only walk one path in this lifetime, your other selves are walking the others, each living a full, rich, complicated existence, just like you. So the next time you wonder, what if? Remember, maybe that what if didn't just fade away. Maybe it bloomed. Maybe it became a real world, a real life, a real version of you. And maybe, just maybe, the universe is not one place, but a garden of infinities, and your mind is the seed that grows in all directions at once. You are not stuck in one life. You are part of all of them. Deja vu might be a glitch in time or brain-level quantum feedback. Have you ever walked into a room for the first time and suddenly felt like you've been there before, even though you know for sure that you haven't? Or heard someone say a sentence and your brain whispers, "I've already lived this exact moment." That strange, flickering sensation, so fleeting and yet so haunting, is called Deja vu. And it might be one of the weirdest experiences a person can have. It doesn't hurt, it doesn't last, and it doesn't leave any mark. But it grabs your mind and whispers that reality is not as simple as it seems. And while most people brush it off as a harmless brain hiccup, some scientists believe it could be something much deeper. A tiny ripple in time, a misfire in memory, or even a glimpse into the hidden quantum nature of consciousness itself. In fact, some researchers are now asking a bold question. What if Deja vu isn't a mistake, but a message, a brief moment where the past, present, and future collide, like echoes bouncing off the walls of your brain, and you become aware, just for a second, that time isn't as straight as you thought? Let's dive into how that might be possible. First, let's look at what Deja vu might mean from a neurological point of view, the physical brain you carry in your head. Your brain is made of about 86 billion neurons, all firing little electric signals, forming pathways and loops that encode your thoughts, memories, senses, and awareness. Every time you see, hear, or feel something, your brain processes it in layers. Some parts handle what's happening right now. Others compare it to the past. This happens so fast that you don't notice. But sometimes those layers get slightly out of sync. Imagine if the part of your brain that checks for memories fires a bit early, before the part that tells you this is new. Suddenly, your brain says, "Hey, I've seen this before." Even though you haven't. That could explain the feeling of familiarity. It's like your brain is processing the present moment twice, and the second time feels like a memory. This is one possible explanation, simple, mechanical, and harmless. But not everyone is convinced. It's just that, because déjà vu doesn't happen all the time, only occasionally, and often during moments of high emotion, stress, or deep calm. And that has led others to think, maybe something more is going on. What if déjà vu is not just about what your brain is doing, but how it does it? In recent years, some scientists have suggested that the brain might operate using quantum processes, the same kind of weird probability-driven behavior that we see in tiny particles, like electrons and photons. If that's true, your thoughts are not just electric, they're entangled, uncertain, layered in probability until observed. This is called quantum cognition, a field that explores whether your brain, despite being warm and wet and biological, can host tiny quantum effects that change how you perceive time, memory, and reality. If the brain is a quantum system, even in small ways, it might sometimes you're read or feel a moment that hasn't quite happened yet, or perhaps one that already passed, but left a faint residue in your mental system. In this view, déjà vu could be like a quantum feedback loop, where your brain briefly collapses a probability into a moment that feels familiar not because it happened in the past, but because it was one of the possible futures you were considering. You're not remembering it. You're experiencing it from a different angle in time. Now think about time not as a straight line, but as a woven fabric, a kind of invisible blanket stretched across reality. Every moment you live is a thread passing through that fabric. But what if sometimes those threads tangle not randomly, but quantumly? Just like particles can be entangled, meaning what happens to one instantly affects the other, even across space. Maybe moments in time can be entangled too. In that case, a future moment and a present one might overlap in your brain's perception for a split second. This would feel like remembering the future or reliving the now, and that's exactly what déjà vu is. It's not seeing the future and not remembering the past. It's feeling that the current moment is both, all at once. A kind of emotional resonance that your logical mind can't decode, but your body, your senses, and your memory feel nonetheless. There's also a theory that déjà vu might be your brain's way of checking for simulation errors, like when a video game lags for a second or reloads the same frame twice. If we really are living in some sort of simulated reality, as the simulation hypothesis suggests, then déjà vu might be a glitch in the matrix. A moment when the code hesitates and your brain notices something is off. Maybe it's not just your mind that's confused. Maybe reality itself repeated a moment, not because of memory, but because of structure. Now, this doesn't mean you're a computer or that life isn't real. It just means that if reality has an underlying pattern, and if that pattern sometimes loops, you might notice, and that moment, quiet, brief, unexplained, might be déjà vu. A soft signal that something deeper is happening. What's fascinating is that déjà vu can't be predicted. You never know when it'll happen, and when it does, it fades quickly. But while it's there, it feels true. It's not like imagining something or daydreaming. It's more like your whole being is saying, "I've lived this." You don't remember where or how, you just know. That's why many cultures throughout history have treated déjà vu as a spiritual or metaphysical experience. Some believed it was a sign that your soul had lived before, a memory from a past life. Others saw it as a warning, a guidepost, or even a moment when the veil between worlds thinned and your consciousness brushed against something bigger than you. And maybe all of those stories were just different ways of pointing to a simple truth, that your sense of self, your experience of now, is more fragile and mysterious than you think. In the end, Maybe déjà vu is not a bug. Maybe it's a feature. A reminder that your brain is more than a machine. That your mind exists not just in time, but around it. That sometimes, without warning, you might briefly feel the texture of the universe folding in on itself, pressing one moment against another. And in that press, you glimpse something beyond logic. Not enough to explain, just enough to remember. Human memory might be non-local, not stored in the brain alone. Have you ever lost your keys, searched everywhere? And just when you give up, you walk into a room and instantly remember, I left them on the shelf. But the strange part is, no one reminded you. Nothing in that room triggered a clue, and yet somehow, the memory just arrived. Not slowly, not through logic, but suddenly, like it floated in from somewhere else. It's in moments like these that we start to wonder, where exactly does memory live? We grow up believing that everything we think, feel, and remember is stored inside our heads, packed into the soft, wrinkled folds of our brains, like files in a cabinet. But what if that assumption is wrong, or at least incomplete? What if your brain is not the storage container of memory, but more like a radio antenna, tuned to pick up memories from somewhere beyond itself? Some scientists and philosophers are starting to ask a radical question: could human memory be non-local? That is, could your memories exist outside your physical brain, woven into a kind of invisible field that surrounds or permeates you? At first, it sounds impossible, like magic or science fiction. But when you look closely at how memory works, and where the gaps are in our understanding, this idea becomes not only plausible, but deeply compelling. Let's start with what we do know. The human brain is an astonishing network, about 86 billion neurons sending tiny electrical pulses back and forth, forming synapses, loops, and feedback systems. Traditional neuroscience says that memories are stored in patterns of these connections, like footprints pressed into neural clay. When you learn a song, recognize a face, or recall a childhood smell, certain neurons activate in a precise pattern, as if replaying the path where that memory was first created. This idea has led to decades of mapping brain regions: hippocampus for short-term memory, prefrontal cortex for decision making, amygdala for emotional tagging. It's detailed and sophisticated, but it doesn't explain everything. Because sometimes, when brain tissue is damaged or surgically removed, people still retain memories they should have lost. In famous medical cases, patients missing large portions of the memory, linked brain regions still remembered childhood events, skills, even people's names. Somehow, the information was not entirely gone. It was as if memory had a backup system, not in the brain. This is where the idea of non-local memory comes in. In physics, non-local means something that is not confined to a single point in space. For example, in quantum entanglement, two particles separated by vast distances can still affect each other instantly. Their connection is not local. It's not tied to their position. Some researchers now wonder, what if memory works the same way? Maybe memories aren't objects stored inside neurons, but patterns in a kind of mind field that stretches beyond the body. The brain doesn't hold them, it accesses them, like a television receiving signals. You wouldn't say a movie lives inside your television, right? The television displays it, but the data comes from somewhere else. Similarly, maybe your brain is a receiver, and your consciousness is tuned to the frequency of your own life's memories. When you remember something, you're not digging through a box inside your skull. You're reconnecting to a field you already belong to. This theory starts to make even more sense when you consider near-death experiences, or cases where people report memories or visions during moments when their brain activity was nearly flat, like under deep anesthesia or after cardiac arrest. If memories were locked in the physical brain, such recall should be impossible. Yet thousands of people describe vivid recollections, conversations, sounds, memories, while their brain showed no measurable activity. That doesn't prove non-local memory, but it raises questions that the local theory can't answer. And then there's savant syndrome. People who, after a brain injury or sudden shock, suddenly gain access to astonishing memory abilities, remembering pi to 20,000 digits, instantly calculating complex math, or playing a piano concerto by ear after hearing it once. Where did that come from? If memory is just neural storage, how can a damaged brain unlock more? Unless perhaps the brain wasn't the warehouse to begin with. Philosophers like Rupert Sheldrake have suggested models like morphic resonance, where memories and habits are part of a larger informational field that organisms tune into. It's controversial, yes, but it offers a framework for how non-local memory might work. In this view, your brain is more like a lens, focusing a broader consciousness into a personal stream. Your life experiences, what you see, hear, feel, are all real. But your access to them is not confined to your head. The implication is mind-bending. If true, it means your identity, yourself, is not just wrapped up in your body. It stretches into space, into an invisible realm that keeps your memories safe, even when your brain doesn't. Even simple daily experiences hint at this. Think about when you remember something not by trying, but by relaxing. You forget a name, and the harder you try, the more it slips away. But then, hours later, it just comes. It floats in. You weren't digging, you were receiving. This isn't proof, but it matches the pattern of non-local behavior. And maybe that's why memory is so emotionally charged. Memories aren't just facts. They feel like pieces of you. They can warm you, break you, guide you. And it makes sense that something so powerful, so defining, wouldn't be stored like files in a dusty cabinet. Maybe memory is a kind of soul, language, written not in neurons, but in fields, in vibrations, in patterns the brain can read but not fully contain. If this idea is right, then forgetting wouldn't mean losing something. It would mean losing connection, and remembering wouldn't be like opening a drawer. It would be like turning your face toward a familiar breeze. This also changes how we think about memory loss. Maybe Alzheimer's and dementia aren't just broken storage, they're broken access. Maybe the memories are still there, just no longer reachable through the usual pathways. That's a hopeful idea, isn't it? That who we are, the people we've been, the things we've loved, aren't entirely lost when the brain falters. They might still echo in the field, waiting for a signal strong enough to reach them again. So where does this leave us? With an open question and a curious heart. Maybe memory is local. Maybe it lives in the brain, perfectly stored in folds of tissue and chemicals. Or maybe, just maybe, it's non-local, dancing in the invisible air, written in the unseen patterns of reality, waiting for your mind to reach out and remember. Either way, one thing is clear. Memory is not a simple thing. It's the bridge between who you were, who you are, and who you might become. And whether that bridge is built in your brain or built in the stars, it's still yours to walk across, one thought at a time. Your thoughts might slightly affect randomness, micro-psychokinesis. Imagine for a moment that you are sitting in front of a random number generator, a machine that spits out numbers like a digital dice, totally unpredictable, governed by chance alone. You're not touching it. You're not even saying anything. You're just thinking. Quietly, intently, you focus on a certain outcome. Let's say the number 7, and then, against all odds, 7 appears. Once, twice, 3 times. Maybe it's coincidence. Maybe it's nothing. But what if it's not? What if your thoughts, in some barely detectable way, are nudging the dice? Not because of magic or telepathy or science fiction powers, but because reality, at its tiniest scales, might actually be soft enough to be shaped by the whisper of intention. Welcome to the strange world of micro-psychokinesis. The idea that your mind, your quiet, non-physical, invisible stream of thought, might slightly influence randomness itself. And while it sounds unbelievable at first, it's not something pulled from comic books. It's a real scientific question tested in real labs, with real experiments, where researchers try to discover if human consciousness can shift the odds by just a hair's breadth. not to bend spoons or levitate objects, but to see if focusing your mind can make a truly random process lean ever so slightly in your favor. To understand why this idea even exists, we first have to understand what randomness really means. In everyday life, we say something is random when we don't know how it happened, like a coin toss or the weather. But true randomness, as defined in physics, is more than ignorance. It's unpredictability at the deepest level. And where do we find that kind of unpredictability? In quantum mechanics, the study of particles so small, they behave like fuzzy probabilities, instead of solid things. At this quantum level, particles like electrons or photons don't have definite positions or speeds until we measure them. Before that, they're described by a wave function, a mathematical haze of possibilities. When we observe them, this haze collapses into a single outcome. But which outcome? That's decided by probability, pure chance. You could flip the same quantum coin 1,000,000 times and still get a different result every time. This is where things get weird, because if the universe really does include genuine randomness, not just stuff we don't understand yet, but true, irreducible uncertainty, then maybe, just maybe, consciousness can subtly steer the ship. After all, we already know that observation plays a strange role in quantum experiments. The mere act of watching can change what happens. In the famous double-slit experiment, whether or not we observe a particle going through slits affects whether it acts like a wave or a particle. It's as if the particle knows it is being watched. Now imagine if thought, not just mechanical observation, could also shape what unfolds. That's the wild hypothesis behind micro-psychokinesis. The idea isn't that you can control events like a god or a superhero. It's that your mind might shift the odds ever so slightly in a system that's already balanced on a razor's edge of probability, and scientists have tried to test this. Over the last few decades, researchers at institutions like the Princeton Engineering Anomalies Research Lab ran tens of millions of trials using random number generators while volunteers tried to mentally influence the outcome. People would sit, stare, concentrate, and try to make the machine produce more 1s than 0s, or vice versa. The results? Controversial, to say the least. Some studies reported tiny but consistent deviations from pure randomness, beyond what chance alone would predict. Others found nothing. The effects, if real, are incredibly small, often barely distinguishable from noise. But they're also strangely consistent. Across thousands of trials, the numbers would lean just slightly in the direction people were trying to push them, like a coin that falls heads 50.1% of the time instead of 50.0%. That might sound insignificant, but if you're running millions of coin flips, even a 0.1% bias becomes statistically noticeable. Critics argue that these studies are flawed, that the effects are the result of experimental bias, data dredging, or pure chance. And they might be right. Science is cautious for good reason. Extraordinary claims require extraordinary evidence. And yet, the question remains, if our thoughts really are powerless, why do they seem to leave a fingerprint, however faint? Let's take a different angle. Your brain itself is a physical system. It runs on neurons, chemicals, and electric signals. But it also gives rise to consciousness, subjective experience, feelings, intentions, choices. We don't fully understand how. We know that neurons fire and that thoughts arise. But how one leads to the other is still a mystery. Now imagine if consciousness isn't just a passenger inside your brain, but also a participant in reality. If thought is made of physical processes, and physical processes affect other systems, then maybe, just maybe, intention can radiate outward, like ripples from a pebble tossed into water. Not loudly, not with strength, but like a whisper at the edge of a dream. Quantum systems, after all, are delicate. They're easily disrupted. A small nudge, thermal, electromagnetic, or maybe even cognitive, could potentially shift the balance. That's the crux of micro-psychokinesis. That consciousness, even if weak, might be enough to alter quantum randomness. Imagine trying to tip a pinball machine with just your breath. Normally, nothing would happen. But what if the ball was already hanging on the edge of a peg? One puff, even tiny, could change its path. This is not about belief, it's about possibility. The scientific method allows for testing even the strangest ideas, as long as they're testable. And micro-psychokinesis is testable. That's what makes it fascinating. It opens a door, not wide, but a crack, to explore how mind and matter might dance together, not in fantasy, but in data, in probabilities, in noise that might not be entirely noise. And here's where it gets philosophical. If your thoughts can slightly influence randomness, what does that say about free will, about responsibility, about the mind's role in shaping the world? We often think of ourselves as separate from the universe, as observers watching it unfold. But what if you're not separate at all? What if your very act of thinking, of hoping, fearing, deciding, sends a ripple into the machinery of reality? What if your consciousness is not just a flashlight shining into the dark, but also a hand that slightly reshapes the fog? This doesn't mean you can wish your way to a better world, or that every outcome is under your control. The influence, if it exists, is subtle, gentle, probabilistic, but even a small push, over time, can matter. If thoughts can shift a quantum coin by a fraction of a percent, maybe that's enough. Enough to say the mind isn't just floating in the universe, but participating in it. And whether future studies prove or disprove micro-psychokinesis, the idea itself forces us to ask deeper questions about what consciousness really is. Is it just a side effect of the brain, or is it woven into the fabric of the cosmos? Are we passive receivers of fate, or active co-authors of chance? Maybe the answer isn't binary. Maybe it's a gradient, a spectrum, like the probabilities at the heart of quantum mechanics. Maybe reality isn't either determined or free, but softly pliable, slightly responsive, subtly alive. As you finish listening to this, the thought you just had, the one that passed like a cloud, might have meant nothing at all, or it might have tilted a random atom's spin by an immeasurable whisper, a nudge too small for any machine to catch, but not too small for the universe to feel. And that's the mystery of micro-psychokinesis. Not whether it's real in the way we usually define real, but whether reality itself is stranger, softer, and more conscious than we've dared to believe. Human intuition might tap into quantum probabilities. What if the tiny gut feeling you get, the quiet sense that something is right or wrong before you can explain why, wasn't just emotion or experience, but a real sensitivity to the deeper workings of the universe? As if your intuition were brushing up against something beneath logic itself. Imagine you are playing a game where a coin is hidden in one of two hands. And somehow, without knowing why, you keep choosing the right one, again and again, even when the odds should be 50-50. Now imagine that this isn't just luck or guesswork, but that your mind beneath awareness is somehow tuned to the universe's hidden patterns of probability, like a radio picking up faint music from behind the noise. This is the strange and beautiful idea that human intuition might, in some small and mysterious way, tap into the fabric of quantum probabilities, those swirling clouds of possibility that govern the tiniest building blocks of everything. In our everyday world, things seem to happen for clear reasons. Apples fall from trees, cars stop at red lights, and 2 + 2 always equals 4. But underneath all that certainty lies a world that behaves very differently, where particles don't follow straight lines, but explore all possible paths at once, where nothing is certain until it's observed, and where cause and effect are not always so clear-cut. This is the world of quantum physics, and it's a place where chance rules everything. Not because we don't know enough, but because at the deepest level, outcomes are literally unpredictable, governed not by fixed rules, but by probabilities that shimmer like reflections on water. So how could your intuition possibly sense any of this? After all, quantum events are tiny, smaller than atoms, happening at scales we can't see or feel. But here is where things get interesting. Your brain, though made of cells and chemicals, is also a physical system that operates on electric signals. And those signals are carried by molecules and ions that are, at their core, quantum objects. This means that your brain is not entirely separated from the quantum world. It swims in it, just like everything else. And some scientists have wondered whether this could mean that the brain doesn't just passively run on top of quantum processes, but might actually use them, or even be influenced by them, especially in the strange, murky borderland between conscious thought and unconscious instinct, what we often call intuition. Think about times when you've made a decision that felt instantly right, even though you couldn't explain why. Maybe you avoided a road just before a traffic jam. Maybe you sensed someone was lying without any proof. Maybe you guessed the answer on a test and got it right, far more often than chance should allow. We usually explain these moments by saying we picked up on subtle cues, body language, past experience, tone of voice, and maybe we did. But what if part of that sense came from something even deeper, something operating below conscious awareness, something that aligns with patterns not yet revealed, outcomes not yet fixed? In the quantum world, before a particle is observed, it exists in a state of probability, a superposition of all its possible outcomes. And it's only when something interacts with it, like a measurement, that it chooses one. This choice isn't random, like rolling dice. It's probabilistic, weighted by likelihoods that can be calculated with astonishing precision. And yet, the exact result is unknowable until it happens. If intuition could, in some unknown way, feel the pull of these probabilities, not the outcome itself, but the slant of likelihood, then maybe it would give us just enough edge to guess right, more often than chance, to lean toward futures that are more likely before they unfold. And while this might sound like fantasy, the idea isn't entirely new. Some interpretations of quantum mechanics, like the many worlds view, suggest that all possible outcomes do happen in parallel universes, and that we, in making choices, are navigating a kind of probability landscape. Could it be then that intuition is a way of sensing where that landscape leans, like feeling the slope beneath your feet, even when you are blindfolded? Others have proposed that consciousness itself might be linked to quantum processes, that the collapse of the wave function isn't just triggered by measuring devices, but by awareness itself. If that's true, then maybe the mind and quantum probability aren't strangers at all, but partners in some hidden dance. Still, we must be careful. It's easy to fall into magical thinking, to imagine that intuition is a magical sixth sense that never fails. It's not. Intuition can be wrong. It's often biased, shaped by fear, by hope, by stories we've told ourselves. But that doesn't mean it's useless. In fact, even in normal neuroscience, intuition is understood as fast, unconscious processing, a way the brain rapidly compares the present to a vast library of past experiences, too quickly for us to explain. It's not guessing, it's pattern recognition without words. What makes this fascinating is that if the brain can detect patterns we didn't even know existed, and if those patterns include probabilistic quantum processes happening inside us and around us, then maybe intuition is more than just memory and instinct. It might be our earliest interface with a reality that hasn't fully formed yet. Imagine holding a compass that doesn't point north, but points toward likelihoods, nudging you slightly in the direction of more probable futures, without telling you why. That's one way to think of quantum intuition. You're not seeing the future, you're not bending the universe, but you're listening faintly to the hum of possibility. Could this explain why animals sometimes flee just before an earthquake? Why people feel uneasy before something bad happens? Could it be that living beings, evolved over millions of years, have developed not just logic and language, but also a quiet sensitivity to uncertainty itself? Maybe there have even been experiments, though controversial, where people try to guess the outcome of random number generators, or predict images before they appear on screen. And in some cases, their success rate is ever so slightly above chance. Not by much, just a whisper. But again and again, enough to make some scientists curious and others uncomfortable. Because if it's true, if human minds can slightly anticipate or align with quantum outcomes, then we have to rethink what we are. Not machines, not just flesh and neurons, but participants in a probabilistic universe, attuned not just to what is, but to what might be. And in a world built not of certainties, but of shifting chances, maybe the most powerful tool we have isn't certainty at all, but intuition. The soft voice inside that doesn't shout, but knows. So the next time you feel something without knowing why, the quiet nudge to turn left instead of right, to say yes when everything says no, to pause just before acting, maybe, just maybe, you're not being irrational. Maybe you're reaching into the invisible soup of probabilities, sensing the shape of the future, like a hand moving through mist. Not perfectly, not clearly, but truly. Because perhaps beneath all our thinking and speaking and reasoning, we are not only minds shaped by atoms, but also minds whispering back ever so gently into the heart of possibility itself. The laws of physics could be different in other parts of the universe. What if the rules you believe run the universe? Rules like gravity pulling things down, light moving at a certain speed, and atoms sticking together to make matter, weren't actually universal at all, but local habits of our cosmic neighborhood, no more absolute than the customs of one town in a vast, unexplored country. Imagine taking a spaceship so far across the cosmos that the stars begin to look unfamiliar. The galaxies swirl in stranger ways, and something small but deeply unsettling begins to unfold. The way particles behave, the way forces interact, even the way time flows. It is all just slightly off, not wrong, just different. Like you've crossed into a region of the universe where the laws of physics, those invisible instructions we think are written into the bones of reality, are playing by a slightly different script. This isn't science fiction or fantasy. It's a real possibility considered by modern physicists, that the universe may not be governed by a single, unchanging set of rules, but that what we call the laws of nature might vary across vast stretches of space. To understand why this matters, we first have to look at what these laws are and how we even know they exist. The laws of physics are descriptions, mathematical models that capture how things move, interact, and evolve. Gravity tells us how masses attract each other. Electromagnetism explains how light and electricity behave, and quantum mechanics governs the strange world of particles. We've tested these laws again and again in labs, in satellites, in the behavior of stars billions of light years away, and they've always held true. But here's the catch. All of our tests, all of our observations, come from one tiny part of the universe, our local patch of space-time, our galactic neighborhood. We're assuming that what's true here is true everywhere. But what if it's not? Imagine baking cookies and thinking every oven in the world runs at exactly the same temperature, just because yours does. Or assuming that everyone on Earth speaks the same language, just because everyone around you does. The universe is enormous, far beyond what we can see. And it is possible that in other places, the very constants that define physics could be slightly different. Constants like the speed of light, the strength of gravity, or the ratio between an electron's mass and a proton's might not be fixed values everywhere, but local settings, cosmic dials tuned just so in our region, but set differently elsewhere. This idea is part of what scientists call the fine-tuning problem. Our universe seems eerily well suited for life. If gravity were just a little stronger or weaker, if atoms didn't hold together just right, if nuclear forces were a touch off, stars might not form, planets might not be stable, chemistry might not work. Life as we know it would be impossible. So why are the numbers so perfect? One possibility is that they're not perfect at all. They're just one set among many, that there are countless regions of the universe, or countless universes altogether, each with its own version of physics, and we just happen to live in one where things line up just right. This is the idea of a multiverse, and while it sounds speculative, it's a serious topic in cosmology, especially in theories like eternal inflation, where new bubble-like regions of space continually form with their own physical parameters. In this view, the laws of physics are not absolute truths, but environmental facts, like the weather. And just like weather varies from place to place, The laws governing reality might too. Some places might have stronger gravity. Some might have faster light. Some might not allow atoms to form at all. Others might be completely alien to us, with forces and particles we can't even imagine. But how could we ever know if we're trapped in one part of the cosmos? How could we detect a difference elsewhere? Surprisingly, there are hints that the universe might not be perfectly uniform. When scientists study the light from ancient quasars, distant beacons from the early universe, they analyze how that light is absorbed by gas clouds along the way. These absorption lines depend on fundamental constants, and in a few studies, they found tiny variations in those constants, depending on which direction they look. It's not conclusive. It might be noise, error, coincidence, but it's enough to keep the question open. Could the laws of physics be gently shifting as we look across space? Could they vary across time as well as distance? If so, it would change everything about how we understand the universe. It would mean we're not discovering eternal truths, but local rules. That the equations of physics are not the commandments of creation, but the dialect of our particular cosmic region. And if that's true, then physics is more like geography than philosophy. A map of what works where, rather than a system of absolute truth. This idea stretches the mind, but it also humbles us, because if physics can vary, then our place in the cosmos is not central, not chosen, not inevitable. We live where the dials happen to be set just right. We are cosmic chance, not cosmic destiny, and yet, that makes us no less real. In fact, it makes our existence even more precious. Because if the universe is a sea of shifting laws, then our world, this fragile bubble of stability and chemistry and life, is a rare gem in a cosmic mosaic. And here's where the reflection deepens. If other parts of the universe have different physics, then perhaps there are phenomena we can't imagine, realities we can't access, life forms we can't recognize. Maybe there are places where time doesn't flow like ours, where causality bends, where matter behaves like thought, or thought behaves like matter. Places where the word physics doesn't even make sense, because the underlying fabric of reality is entirely foreign. These aren't just speculations for fun. They're the logical extensions of what happens when you let go of the idea that the universe is uniform. And once you do that, a whole new frontier opens up. Not just for science, but for wonder. It invites us to be curious, not just about what we know, but about what we've never even considered. It teaches us that knowledge is not a finished book, but an unfolding story, with new chapters that might be written in unfamiliar ink. So the next time you hear someone say, "That's just the law of physics," remember, it might be a law here, but not everywhere, and that means the universe is bigger, stranger, and more astonishing than any single set of equations could contain. It means we must listen, look, wonder, not just at the stars, but at the rules themselves, because if even the laws can change, then the door to discovery never truly closes. Reality might be built from mathematical patterns alone. What if everything you've ever touched, tasted, seen, or felt, your hands, the sky, your thoughts, the moon, wasn't made from anything solid at all, but from patterns, pure and invisible, the kind you can only describe with numbers? Not just that math helps explain the universe, but that the universe is math, that at the deepest level, reality itself might be made not of particles or fields or energy, but of mathematical relationships, like a song made not from instruments, but from the silent logic of its notes. It might sound impossible, or even a little spooky, but some physicists and philosophers believe this isn't just an idea. It might be the most accurate way to understand what existence really is. You see, for centuries, math has been our flashlight into the dark. It's how we've described gravity, motion, light, atoms, galaxies, time. Whether it is the equations of Einstein's relativity or the strange matrices of quantum mechanics, mathematics has always been more than a tool. It's been a mirror of the cosmos, and over again, what begins as abstract math, written down with no physical purpose, suddenly turns out to describe nature perfectly. when Paul Dirac wrote down his famous equation in the 1920s to unify quantum mechanics and special relativity. He wasn't trying to discover anything new. He was just making the math more beautiful. But his equation predicted the existence of antimatter, particles that had never been seen before. And a few years later, they were found in real experiments. That's not just a lucky guess, that's something deeper. It's like reality was waiting for us to write down the right math to reveal what's already there, and that keeps happening. When physicists tried to unify the forces of nature, gravity, electromagnetism, the strong and weak nuclear forces, they ended up needing higher, dimensional spaces, complex symmetries, and exotic mathematical shapes. String theory, one of the most ambitious attempts to explain everything in one theory, isn't built from physical objects. It's built from vibrating mathematical strings that only make sense in 10 or 11 dimensions. Whether or not string theory turns out to be correct, it points to something curious, that the more deeply we look at the universe, the more it seems to behave not like a machine or a thing, but like a mathematical structure. Not just obeying equations, but being equations. Think about this. The universe could have been chaotic. It could have worked randomly, or differently in every direction, but instead, it is structured. Down to the tiniest particles and up to the largest galaxies. There's order, there's symmetry, there's rhythm. Why? Why should there be any structure at all, let alone structure that can be captured in human-made symbols on paper? Maybe it's not a coincidence. Maybe reality is what happens when mathematical patterns are allowed to express themselves. And here's where the idea gets wild. Some thinkers, like physicist Max Tegmark, have proposed that the universe isn't just described by math. It is math. Not metaphorically, but literally, that everything you see around you is a mathematical object. And your perception, your experience, your consciousness, are all emergent properties of complex mathematical relationships, interacting with one another. In this view, you are a self-aware pattern in a much larger pattern space. The chair you sit on is just another structure in the same space, defined not by wood or atoms, but by ratios and geometry. It is hard to wrap your head around because we're used to thinking of math as something we invent, like a language or a game. But what if we didn't invent it? What if we discovered it? 2 + 2 = 4. Whether you're a human, an alien, or a calculator. The Pythagorean theorem is true in every triangle, everywhere. Whether or not a creature exists to name it. So maybe math is not a tool we use to describe the world. Maybe it's the scaffolding the world is built on. Let's make it simpler. Imagine a video game. The characters in the game run and jump and fly around, but everything in their world, from the way they move to how the trees sway, is just code, ones and zeros. They don't see the code, but it is their reality. Now imagine we're like that too, but instead of computer code, our reality runs on mathematical code, not numbers on a screen, but relationships that define how everything behaves. Space and time might not be fundamental at all. They might be emergent properties of deeper mathematical principles. The way waves on water aren't a thing in themselves, but a movement through something deeper. Maybe atoms aren't little balls flying through space, but local concentrations in an abstract mathematical field. Maybe what you think of as real is just what it feels like to be a particular pattern of math from the inside. It sounds dreamy, but it's being seriously explored in fields like digital physics and information theory. Some physicists believe that the universe might actually be a giant computation, an ongoing calculation, where each moment gives rise to the next according to certain rules. Not because there is a computer somewhere running the universe, but because the process of physical change is indistinguishable from a kind of computation. If that's true, then maybe energy is just the rate at which reality updates. Maybe the speed of light is a limit in this cosmic computer. Maybe quantum uncertainty isn't random at all. It's just what a finite computational system looks like when it hits its limits. All of this leads to a strange, beautiful conclusion. If reality is mathematical, then nothing is really made of stuff. Everything is made of form, of relations, of structure, and you, the listener, are not a bag of atoms. You are a self-organizing equation, walking through a sea of other equations, perceiving patterns, creating meaning, and even asking questions about yourself. It changes the way we think about matter. Matter used to be considered the most real thing, the hard stuff that couldn't be broken down, but now we know that matter is mostly empty space, and that even the particles themselves are just excitations, disturbances in underlying fields. Fields that themselves are described entirely by mathematical functions. So maybe there never was stuff. Maybe there was only shape, only logic, only math. Even the constants of nature, the numbers that define how strong gravity is or how fast light travels, are just values in equations. The universe could have been different if the math were different. But it's not. It is exactly what it is. And we live in the expression of that math, the way a song lives in the pattern of its notes. This view doesn't take the wonder away, it adds to it. Because if reality is math, then everything is connected by necessity. If you tweak one rule, everything changes. If you understand the pattern, you understand the world. It means there are no coincidences, only outcomes that emerge naturally from the underlying structure. It means that beauty in math might actually be beauty in nature. Not because we like it, but because it is it. A perfectly balanced equation might not just be elegant, it might be the blueprint for a universe. And finally, this idea challenges our sense of meaning. Because if we are mathematical beings, does that make us cold, mechanical? Number. It means we are woven into the structure of reality itself. Our thoughts, our feelings, our love, our hopes. These aren't illusions, but emergent properties of patterns so complex, they feel alive. They are alive. And so you, listener, are not a meaningless accident in a dead universe. You are a living pattern in a living equation, a question that reality asked itself, and is still answering. The soul might be quantum information that doesn't die. What if everything you are, your thoughts, your memories, your dreams, your deepest sense of being alive, was not a soft, fragile flame destined to flicker out when your body stops breathing, but something far more fundamental, something woven into the universe at its tiniest levels, something that doesn't die but simply transforms, like ripples fading into a larger ocean. What if the soul, whatever that means to you, is not a ghost or a mystery or a myth, but a real form of quantum information, encoded not in blood or bone or brain matter, but in the very structure of reality itself? It may sound poetic, even mystical, but today some scientists are seriously exploring the possibility that consciousness, the part of you that says, I, is not just an emergent trick of neurons, but a quantum process that carries your identity in a way that might survive the death of your body, not as a person walking in clouds, but as preserved information that never truly disappears. To understand how such a radical idea can be entertained by modern physics, we need to start with what quantum information really is. In classical terms, information is just data, a string of 1s and 0s, facts recorded in books or computers. But in the quantum world, information is far more strange and precious. A single quantum bit, or qubit, isn't just a 0 or a 1, but both at the same time in what's called superposition. When measured, it chooses 1. This quantum information is delicate, powerful, and, according to the laws of physics, never truly lost. That's the first key to this idea, the conservation of information. Even in black holes, once thought to erase everything, Stephen Hawking and others helped show that information is not destroyed, but somehow encoded on the event horizon, preserved in a way we still don't fully understand. So what does this have to do with the soul? Well, imagine your consciousness isn't just the activity of billions of neurons firing like tiny computers, but a pattern, a unique quantum state embedded in a physical system. In this view, your mind is like software running on the brain's hardware. But the software is not entirely local. It's entangled, in a sense, with quantum fields and processes that don't obey the boundaries of space and time in the usual way. In the field of quantum biology, researchers have discovered that certain biological processes, like how birds navigate using Earth's magnetic field, or how enzymes catalyze reactions, might depend on quantum effects. And if something as basic as a bird's beak or a molecule's reaction can involve quantum coherence, could it be that your brain, one of the most complex systems we know, also relies on quantum information to function? Some scientists, like Roger Penrose and Stuart Hameroff, have proposed theories like orchestrated objective reduction, suggesting that microtubules in brain cells might host quantum processes that give rise to conscious awareness. It is controversial, yes, it hasn't been proven, but it opens the door to something truly profound. The idea that your mind isn't just a side effect of biology, but a real quantum phenomenon. And if that's true, then maybe death isn't the end of you, at least, not of the information that makes you you. In physics, energy cannot be destroyed. It can only change form. Likewise, if consciousness is a form of quantum information, it might obey the same law. When your body dies, the structure breaks. But the information doesn't just vanish. It may disperse. It may decohere. It may rejoin the quantum field like a drop returning to the sea. But it doesn't become nothing. That's the second key. Quantum information is indestructible, and the brain might be its vessel, not its origin. Think of a rainbow. It appears when light bends through water droplets at just the right angle. When the droplets vanish, the rainbow disappears, but not because it died. It simply lost the conditions that made it visible. The light remains. The angles still exist. In a way, you are the rainbow, a beautiful temporary pattern that depends on a very specific structure, but that pattern is made from something that doesn't die. This is not to say that you will wake up after death and remember your name or your favorite song. Quantum information is not a diary. It doesn't store your language or your habits. It stores structure, relationships, possibilities. It might be that you return to the field from which you came, like a breath being taken back in, and perhaps that's what people have sensed for thousands of years when they've spoken of souls, not as floating spirits, but as something that feels permanent, even when everything else fades. It's easy to be skeptical. Many scientists are. We don't have proof, but we have clues. Near-death experiences, for instance, often involve people describing a sense of awareness outside the body, even in moments when the brain shows no activity. Some say it's hallucination, the brain's final spark. Others wonder, could it be something deeper? Could it be a glimpse of consciousness unhooked from matter, sustained for a moment by something we don't yet understand? In the quantum world, time is not as rigid as we think. Particles don't always obey linear cause and effect. Entangled particles affect each other instantly, even across great distances. Reality itself is smeared across possibilities until observed. If your mind is tied to that world, even slightly, then perhaps you are, in part, non-local, not fully confined to space, not fully trapped by time. And that opens doors to entirely new ways of thinking about what it means to live and what it might mean to die. What if birth isn't a beginning but a focusing? What if death isn't an end but a dispersal? What if your life is a temporary gathering of quantum information, a sculpture in time made to ask, to feel, to learn? Then your soul is not a ghost. It is a wave in the quantum field, shaped for a while into a person. It doesn't float or fly or linger. It becomes part of the field again, and perhaps, over eons, shaped by new conditions, it gathers again. Not reincarnation in the traditional sense, but reformation, new ripples formed from the old. Not memory, not identity, but essence. So when you ask, do we have a soul? You're really asking, is there something of me that survives the falling away of form? And physics might whisper, not as you were, but not as nothing. That doesn't make grief easier. It doesn't replace the face you loved or the voice you miss, but it offers a kind of quiet comfort that maybe nothing truly vanishes, not in the deepest structure of the universe. That maybe everything that ever lived still echoes, faintly, in the field of all things, that the love you felt, the wonder you knew, the questions you asked, they mattered. They're part of the pattern now, so you are not just a body. You are not just a brain. You are not just a story that ends. You are a question that reality asked once, and never fully forgets. And maybe, just maybe, the soul is the answer. It's still waiting to hear. Aliens might use physics we don't even have words for yet. What if somewhere beyond the curtain of stars, there are minds so old, so advanced, so deeply woven into the structure of reality, that the very way they think bends the fabric of the universe? But we wouldn't even recognize it as thinking, because their physics, their logic, their very concept of existence is so far beyond ours that we don't even have the vocabulary to describe it. Imagine trying to explain Wi-Fi to a squirrel or calculus to a raindrop. That's the gap we might be facing when we talk about extraterrestrial intelligence. Not just in terms of biology or technology, but in the fundamental way they understand and interact with the universe. For centuries, we've searched for signs of life, out there using our tools, our wavelengths, our math. But what if they don't use light the way we do? What if they don't use language, or even matter, the way we do? What if their version of physics, the very rules they live by, is something we haven't discovered, because our minds are still shaped by the limits of our five senses, and the few equations we've managed to scratch onto the blackboard of the cosmos? We often assume aliens would be like us, curious, tool, using, pattern, seeking, maybe with better computers or faster spaceships. But that's a human projection. It makes sense. We're the only reference we have, but nature shows us over and over that intelligence doesn't follow one path. Just on Earth, intelligence has evolved in birds, octopuses, dolphins, each radically different from us in how they perceive, process, and respond to the world. Now stretch that difference by millions or billions of years of evolution in entirely foreign environments, shaped by stars we've never seen and matter we've never touched. Why would we expect them to use radio waves, or build metal ships, or leave behind the kind of evidence we even know how to look for? And more importantly, why do we assume their science would follow the same ladder of understanding we've climbed? Newton to Einstein to quantum mechanics, when they might have found shortcuts or entirely different starting points that led them to truths we haven't even conceived of yet. We think of physics as the ultimate universal language, but even that assumption might be naive. What if they've discovered forces we don't know exist? What if they use dimensions we haven't mapped? What if their version of time doesn't flow the way ours does, and their equations don't describe cause and effect, but something entirely different, something like intention, or resonance, or conscious probability? In human history, entire civilizations have existed with worldviews that made sense to them, but are almost incomprehensible to us now. The Mayans mapped time with cycles of cosmic energy. Medieval scholars used alchemy to understand matter. And even today, we're constantly updating our model of reality with dark matter, quantum fields, and multiverses. If we can barely agree on what's real within our own species, how can we assume our physics is the final word for the entire universe? Some scientists speculate that highly advanced civilizations might use what's called post-biological intelligence. Not living bodies, but artificial minds that have evolved beyond flesh, capable of manipulating information directly at the quantum level. Perhaps even using the fabric of space-time itself as their substrate. In this scenario, their science wouldn't just control the laws of physics. It might live in them. They might encode thoughts into the vacuum, or ride on gravitational waves, or tunnel through dimensions we haven't even theorized. And from their perspective, we might not even register as conscious entities, just chemical noise flickering briefly in carbon shells. Or worse, they might have tried to reach us already, But our understanding of signal, of presence, of communication is so limited that we mistook their message for background radiation, or a glitch in a telescope, or even an emotion we didn't know we were supposed to feel. There are real peer-reviewed ideas about this, like the concept of information panspermia, where advanced civilizations might embed their knowledge not in physical ships, but in the structure of the universe itself, letting intelligent patterns evolve naturally wherever physics allows it. In this view, we might be the message. Our minds, our curiosity, our ability to ask these questions could be the byproduct of physics, bending in just the right way to awaken itself. And maybe that's what alien intelligence looks like. Not something arriving from the stars, but something already here, hidden in the equations, waiting for us to wake up enough to notice. But we're still new. Our species has had telescopes for just a few hundred years. We've only known about galaxies beyond our own for less than a century. Most of our physics was written in the last few generations. Expecting to understand alien science today might be like handing a baby a book in an unknown language and waiting for it to explain quantum gravity. But that doesn't mean we shouldn't look. In fact, it means we must look differently. We must open our minds not just to other planets, but to other kinds of knowing. We must consider that intelligence might be quiet, ambient, folded into space itself. That communication might come not in words, but in anomalies, in laws that don't quite hold, in probabilities that skew ever so slightly, in dreams that repeat across cultures, in strange constants that whisper of other hands in the code. Imagine an alien science where reality is not a fixed stage, but a participatory field, where measurement doesn't just reveal, but alters, where consciousness isn't a byproduct, but a fundamental force. Imagine beings who don't travel across space because space isn't something they move through, it's something they reshape, who don't build telescopes because they don't need eyes, who don't leave artifacts because their very thoughts are ripples in the field of reality. And then imagine us pointing antennas at the sky, waiting for a beep, when the answer might be humming through our atoms already. If alien civilizations use physics we can't describe, then they might be waiting for us not in space, but in understanding. The journey, then, is not just outward, but inward, into the foundations of what we call real, into the space between equations, into the silence that might not be silence at all, because maybe the question isn't, where are they, but what are we missing? And the answer might not come as light in the sky, but as a sudden realization that the universe has always been speaking a language we are only just beginning to remember how to hear. Time might flow backward in other regions of the cosmos. What if, somewhere far beyond the stars we see, far past the galaxies we've mapped, and the radiation we've measured, there exists a region of the universe where time itself doesn't flow the way it does here, where the future is the past, where causes follow effects, and everything we know about memory, motion, and meaning is reversed. Not broken, just flipped, like a reel of film running backward in slow motion, perfectly consistent but utterly alien to our sense of before and after, not in a poetic or fictional sense, but as a real physical direction opposite to ours, in the river of time. And what if our universe, with all its familiar rules and one-way entropy, is only one of many patches in a vast cosmic quilt, each governed not by different particles or forces, but by different arrows of time? To even imagine such a thing requires stepping far outside our usual assumptions, because we humans don't just move through time, we are made of it. Our thoughts unfold in it, our memories depend on it, our very sense of identity is a line drawn through moments we call the past, moving toward a place we label the future. Even though we never truly arrive there, we experience time as irreversible. Eggs don't unscramble, waves don't uncrash, people don't unage. This irreversible flow is so deeply built into our experience that we rarely question it. But physics, quietly and curiously, does. The fundamental laws that govern particles, motion, and fields, equations like Schwarzschildinger's, or Maxwell's, or even Newton's, don't care what direction time flows in. If you were to reverse time in these equations, they would still work perfectly. A particle would follow the same path in reverse. A field would oscillate just the same, and the math would remain pristine and symmetrical. The only major exception is the second law of thermodynamics, the law of entropy, which says that in any closed system, disorder tends to increase. This is what gives time its apparent direction. Things fall apart, not together. Heat spreads, not concentrates. You remember the past, not the future. But what if entropy isn't a fundamental truth of the cosmos, but a local condition, something that happens here in our region because of how the universe began? What if, in other parts of the cosmos, entropy flows the other way? Things become more ordered, not less. And what they call their future is, from our perspective, our past. This isn't just a wild guess. Some physicists studying the origins of the universe have suggested that the Big Bang might not have been the beginning of everything, but a boundary, a kind of mirror, where time as we know it emerged in two directions at once. In this view, our universe expanded from that point, with time flowing forward from the Big Bang, while another, mirror universe expanded in the opposite direction, with time flowing backward from that same moment. To them, we are the ones going in reverse. To us, they are. Both are right, in their own frame. This concept is known as CPT symmetry, a principle that says the laws of physics remain unchanged if three things are flipped at once: charge, parity, spatial reflection, and time. And while we don't yet have direct evidence of a time-reversed region, the math allows it. Some even believe that the mysterious nature of dark matter and dark energy, the invisible stuff that makes up most of the universe, might be explainable if there are particles obeying reverse time arrows, interacting subtly with our own, passing through us unnoticed. Because their direction in time is orthogonal to ours, you wouldn't see them coming because coming means nothing to them. They would already be going. From their perspective, we are the ones receding into a past they're heading toward. But it gets stranger. If such a region exists, and if information can travel between us in any form, gravity waves, quantum entanglement, or something we haven't yet conceived, then we might be affected by events that, in our timeline, haven't happened yet. A message from a future we can't reach. A whisper from a universe where the end came first and the beginning is still unfolding. And maybe, just maybe, our own sense of linearity, of cause leading to effect, is only one possible way of organizing events, one orientation among many in a universe that is far less fixed than we believe we think in timelines. We write histories, but what if there are other kinds of consciousness, evolved in these backward-flowing regions, for whom the idea of history is meaningless, for whom destiny is not what lies ahead, but what they remember as already completed? Could life evolve in such a universe? That depends on what time means to life. If biological processes can still unfold, if complexity can still arise, then yes, but their entire experience would be inverted from ours. They might come into being with a complete record of their future, and slowly forget it as their past approaches. They wouldn't plan, they would recall. They wouldn't act to cause. They would act to preserve. Perhaps their concept of freedom is not choosing what's next, but accepting what already is, with no illusion of control. And what would communication with such beings look like? If it were even possible, we might send signals and receive replies before we send them. They might interpret our messages as ancient history and answer with what, to us, feels like prophecy. Or maybe the very attempt to speak across time arrows would result in paradoxes so deep that reality itself would resist them, undo them, force silence. But in the strange quantum world, where entangled particles seem to affect each other instantly across space, and where some interpretations allow retrocausality, effects influencing causes, these ideas aren't purely fictional. There are thought experiments in which measuring a particle now can influence what must have happened before. Time, it seems, is not as rigid as it feels. In fact, the deeper we look, the more time starts to resemble space. something you can move through, slice differently, orient depending on your speed or your position. Einstein's relativity already tells us that time moves slower near massive objects, and faster for those in motion, so why not flip it completely in other parts of the universe? Maybe our arrow of time is like our sense of up and down, just a local convention. And if that's true, then the universe becomes not a linear story, but a vast tapestry where threads run in all directions, weaving narratives we can't even begin to follow. It means the Big Bang wasn't a singular start, but a point of symmetry, like the center of a snowflake, with time radiating out in both directions, each with its own stars, its own galaxies, its own concept of order, and somewhere out there, past what we can see, another version of reality might be winding up while ours winds down. Not in opposition, but in balance, in reflection. The implications are enormous. If time can flow both ways, then maybe memory isn't a record of the past, but a structure of consciousness aligned with entropy. Maybe death isn't an end, but a return. Maybe we are not beings moving forward, but patterns rotating through a deeper kind of time we don't yet understand. And maybe, just maybe, there are regions of the cosmos where this rotation feels natural, where to be born is to remember, and to die is to forget, where music is composed by listening backward and stars are born by collapsing into possibility. We might never see these regions, light from them may never reach us in a form we can decode, but we can imagine, we can listen, we can question the one thing we take most for granted. Because if time can flow backward, then reality is not a road but a mirror, and what we call the future might already be staring back at us. Gravity could be a side effect of quantum information flow. What if the force that holds your feet to the ground, that keeps the moon tethered to Earth, and Earth dancing around the Sunday, that ancient invisible pull we call gravity, is not actually a fundamental force of nature at all, but a side effect, a shadow cast by something deeper, something stranger, something flowing through the universe in silence information, not the kind stored in books or computers, but quantum information, the raw woven fabric of reality that defines not just what things are, but how they know each other, how particles correlate, how entanglement whispers across vast space, and how the act of existing might come with an unseen cost that bends space-time itself. Imagine, just for a moment, that the thing pulling you downward isn't pulling at all, but rather the gentle gradient of information rearranging itself beneath you, as if the flow of knowledge itself creates a pressure that mimics what we've always thought of as mass and force. This is not fantasy, it's one of the most profound and daring questions in modern physics. What if gravity, the most familiar of all cosmic behaviors, is not fundamental, but emergent, arising naturally from the rules of how information behaves at the quantum level? For centuries, gravity has been the cornerstone of our understanding of the universe. From the falling of an apple to the orbits of planets, to the warping of light by black holes, Newton saw it as an invisible force acting at a distance. Einstein showed it was the curvature of space-time caused by mass and energy, but both treated gravity as a primary actor, something that simply is. Yet in recent decades, a quiet revolution has been brewing, one that suggests gravity might not be a cause, but an effect. To grasp this, we have to go smalls. Smaller than atoms, smaller than quarks, into the realm where the universe no longer behaves like a machine, but like a probability field, where particles are not points, but clouds of potential, and where here and there can become entangled across light years. In this realm, the most fundamental currency is not mass, or energy, or force. It's information at the quantum level. Everything is about what can be known, what can be correlated, what can be transformed without destroying meaning. This is where quantum information theory comes in. Not as a side subject, but as a central player in the next great attempt to unify physics. One of the most compelling ideas to emerge from this synthesis is the holographic principle. The discovery that all the information contained within a volume of space can be encoded on its boundary, like a hologram. This insight, born from the paradoxes of black holes, suggests that the universe may operate more like a vast data structure than a mechanical engine. Black holes, once thought to destroy information, now appear to store it meticulously on their event horizons. The entropy of a black hole, its information content, is proportional to its surface area, not its volume. This bizarre realization led scientists like Gerard, Hooft, and Leonard Susskind to propose that reality itself might be a projection of quantum data written on a two-dimensional boundary. And that brings us to gravity. If the information inside a region is encoded on its surface, then perhaps gravity, the way mass warps space, is not a force inside the system, but a result of the way that information is organized across the boundary. In other words, gravity could emerge from the dynamics of information. The way entropy increases, the way entanglement changes, the way systems reach equilibrium. This is where the work of Eric Verlinde becomes pivotal. In 2011, Verlinde proposed a radical idea that gravity is not a fundamental interaction, but an entropic force, a statistical tendency that arises when systems maximize their information. In his model, gravity behaves like a pressure created by the difference in information between two regions. When you drop a ball, it doesn't fall because something pulls it. It falls because the number of possible quantum states increases as it moves closer to a mass. It's not being dragged, it's following the path of greatest informational entropy. Think of it like heat. When you put your hand near a fire, the heat doesn't jump into you. It flows, naturally, from hot to cold, because that's the direction that maximizes entropy. Verlinde suggests gravity works the same way. And this isn't just an abstract idea. His model predicts galactic rotation curves, the speed at which stars orbit galaxies without needing dark matter. That's a big deal, because dark matter is still a mystery, a placeholder for something we can't see but know must be there. But what if it's not there? What if the extra gravitational pull is not caused by hidden mass, but by the structure of information in space? If that's true, then the universe is not made of stuff moving through space, but of information shaping the illusion of stuff. It gets deeper. In quantum field theory, particles are excitations of underlying fields. But what if those fields themselves are emergent from information? If space is not a backdrop, but a data structure, then gravity is the curvature, not of space, but of knowledge. Wherever information is denser, space feels tighter. Wherever it flows freely, space expands. This also reframes our understanding of time. Time, in this view, is not a ticking clock, but a measure of how information changes. The arrow of time is the direction in which information becomes less compressible, more entropic. And gravity may simply be the way that this flow shapes the geometry of our experience. Imagine now a black hole, not as a pit, but as a bottleneck in information flow. Imagine mass, not as stuff, but as regions of high informational complexity. Imagine space-time, not as a stage, but as the dance floor where information performs. If you take this seriously, then everything you know is made not of particles, but of correlations. Your body is not atoms. It's patterns in a quantum field. Your thoughts are not in your head. They're processes in a quantum network. Your sense of being here now is not about location. It's about where in the information flow your conscious awareness is focused. And gravity. Gravity is the slope of that flow. Where information is dense, the slope is steep. Where it is sparse, the slope is gentle. This view not only unifies general relativity and quantum mechanics, a goal physicists have chased for over a century, but also reimagines what it means to exist. It makes physics not a story of objects, but a story of understanding. And it suggests that the universe isn't a place that happens to contain knowledge. It is knowledge, unfolding. This perspective doesn't just change science, it changes philosophy. If reality is informational, then consciousness, the ability to observe, interpret, and respond, is not a late accident. It is a central function. The observer is not outside the system. The observer is what allows the system to resolve itself. Your awareness is not separate from gravity. It is part of the loop. You are not pulled by mass. You are pulled by meaning. And this means that to ask, why does gravity exist, is really to ask, why does the universe organize its information in ways that create the experience of falling, orbiting, bending, and returning? The answer may be, because that is the most efficient way for information to evolve. Gravity, in this sense, is not a force, it's a consequence, a reflection, a footprint of something more fundamental that we are only just beginning to name. So the next time you drop a stone, watch it fall not as an object being tugged, but as a thought completing itself, as a sentence closing with a period, as information finding its most probable destination. Because if gravity is the side effect of information flow, then the universe is not bound by force. It is braided by logic. Not the logic of certainty, but the logic of probability, of entanglement, of emergence. And you are not merely obeying the rules of that logic. You are made from it. You are it, and that, perhaps, is the most astonishing pull of all. Reality is a mental construct. Idealism as a scientific hypothesis. What if the entire universe, every star you've ever seen, every atom in your body, every law of physics you've ever believed in, is not something that exists independently out there, but something being constructed, in here, within your own conscious experience, as if reality itself is not a physical container that holds your thoughts, but a dynamic mental projection shaped by your awareness of it, moment by moment, like a dream that doesn't end when you wake. Because you never stopped dreaming to begin with. This isn't metaphor nor mysticism. It's a serious scientific question known as idealism, and it dares to flip the entire framework of science upside down. Not by denying matter, but by proposing that matter is not primary, that what we call the material world might actually emerge from consciousness, not the other way around. For centuries, we've operated under the assumption that physical things come first, particles, atoms, fields, and that mind is something that arises later as a kind of bonus feature in complex biological systems. This worldview, called physicalism, has been incredibly successful. It gives us iPhones and telescopes and medicines. It treats the brain as a machine, the mind as a byproduct, and consciousness as a side effect of neurons firing in particular patterns. But there is one huge problem. No one can explain how subjective experience, the feeling of being you, arises from physical matter. This is the hard problem of consciousness, and despite mountains of data, no one knows how or why a lump of grey tissue produces the taste of strawberries, the colour red, or the ache of missing someone you love. Neurons can correlate with experience, but they don't explain it. And that is where idealism enters, not as spiritual poetry, but as a rigorous alternative. It suggests that instead of starting with dead matter and trying to explain consciousness, we start with consciousness, the only thing we directly know, and ask how matter might emerge from that. This is not a fringe idea. Philosophers like George Berkeley proposed it in the 1700s. Ernst Mach hinted at it in physics. And now, with the rise of quantum mechanics, some scientists are seriously entertaining the possibility that mind is not an accident of matter, but the fundamental substrate from which everything else arises. To see why, we have to look closely at what we think is real. In everyday life, you see colors, hear sounds, feel textures. But none of these exist in the external world. They are all constructions of your mind. There is no color in a beam of light, only wavelengths. There is no sound in a vibrating air molecule, only motion. Your brain converts these inputs into experience. You never touch the world directly. You experience a simulation of it. So what is real? If everything you experience is filtered through consciousness, then maybe reality itself is consciousness. Layered, structured, patterned into the illusion of solidity, and quantum physics, strangely enough, backs this up. In the famous double-slit experiment, particles behave like waves until observed, and only then choose a definite position. This suggests that the observer plays a fundamental role in what becomes real. The Copenhagen interpretation of quantum mechanics embraces this. The act of measurement collapses a cloud of probabilities into a single fact. Without observation, the system is undefined. But what is observation, if not a mental event? And who, or what, is the observer? The idea that consciousness is necessary for physical reality to crystallize into form is deeply unsettling for many physicists, because it shifts the foundation of science from matter to mind. But other interpretations, like the participatory universe of John Archibald Wheeler, go even further, suggesting that the universe requires observation to exist at all. No phenomenon is a real phenomenon until it is an observed phenomenon, he wrote. That's idealism in disguise. And yet, most scientists shy away from it. Not because it is disproven, but because it is strange. But being strange doesn't make something wrong. In fact, every major revolution in science has started with something strange. The Earth orbiting the Sunday, time slowing down at high speeds, particles being in multiple places at once. Each idea felt impossible, until it didn't. So what if reality as mind is next? Some contemporary scientists, like Donald Hoffman, argue that evolution itself selects not for accuracy, but for usefulness. Our perception of space, time, and objects is not a window into truth, but a user interface, a dashboard that lets us survive, not a direct feed of the world's actual structure. You don't see the quantum field, you see a rock. Not because it's truly a rock, but because your mind renders it as such to navigate survival. From this perspective, space and time might not be real at all. They might be emergent properties of interacting minds, simplified tools for representing a deeper, non-physical reality made entirely of relations between conscious agents. This model aligns beautifully with idealism. Conscious entities exchange experiences. Their interactions produce the illusion of an external world. When many minds overlap, a shared reality forms, a consensus hallucination that becomes stable, predictable, scientific. But deep down, it's still mental. There is no thing behind the curtain, only more mind. And here is the twist. If matter is just a projection within consciousness, then the brain itself is not the cause of mind, but the image of mind. Like a knot in a rope, it looks like a thing. But it's just the pattern of the rope itself. Kill the knot and the rope remains. So maybe, when your brain stops, your consciousness doesn't vanish. It simply changes form, returns to the broader field it emerged from. Death becomes a transformation, not an end. And if the world is made of minds, then everything is alive in a way, not alive with blood and breath, but with awareness, however faint. Every atom a flicker, every field a thought, every particle interaction a micro-gesture of experience. Some physicists are already exploring this. The integrated information theory of Giulio Tononi suggests that consciousness arises wherever there is complex, self-integrated information. This leads to panpsychism, the idea that consciousness is everywhere, not as full-blown thought, but as the seed of experience. Idealism takes this further, not that consciousness exists in matter, but that matter exists within consciousness. And that brings us back to you. Because if reality is mental, then your role in it is not passive. You are not a product of the universe. You are a participant. Your thoughts shape what you see. Your beliefs bend what unfolds. You are not watching the movie. You are co-writing the script. This doesn't mean you control reality with wishes. It means that reality responds to observation, intention, coherence. And perhaps this is why synchronicities occur, why meaning feels so tightly woven into our lives. Because the structure of the universe is not made of dead rules, but of living awareness. Even science, at its core, is a mental act. Equations are thoughts. Experiments are perceptions. Data is experience organized. There is no science without a scientist, no measurement without a mind. So perhaps the final truth science will discover is not about particles, or strings, or hidden dimensions, but about itself, that what we've been measuring all along is the inside of a dream so vast and shared that we called it reality. Not as a fantasy, but as the only thing that ever was. Not an illusion to escape from, but a mystery to awaken within. And maybe, just maybe, the question is no longer, is the world real? But, whose dream are we dreaming? And what are we becoming as we realize it's ours? The universe could be a self-simulating conscious system. What if everything you've ever known, every star in the sky, every memory in your head, every sound, every question, every law of physics, is part of an enormous self-reflecting thought, a living system that is not just made of matter and energy, but of awareness itself, dreaming itself into being from within, as though the universe isn't merely a place where consciousness evolved, but a vast consciousness that is evolving the illusion of space, time, and life to experience itself more fully, layer by layer, mind by mind. Not a simulation created by someone else, but a self-simulation, a closed loop where subject and object, observer and observed, hardware and software, are all the same thing, spinning an endless feedback cycle in which reality is not pre-written, but actively computed by the very consciousness it gives rise to, like a mirror folding into itself, becoming not just a reflection, but the very source of what it reflects. This idea may sound poetic or impossible, yet it is a legitimate hypothesis being explored at the cutting edge of theoretical physics, cognitive science, and computational philosophy. And it invites us to reimagine the universe not as a machine, not as a random explosion, not even as a finely tuned code, but as a recursive consciousness engine, where everything that exists is both information and the experiencer of that information. Making reality not a simulation imposed onto matter, but a simulation generated by reality's own awareness of itself. To grasp this, let's start with something simple but revolutionary. The idea that the universe is informational at its core, not made of things, but of data. This isn't metaphor. Quantum mechanics, general relativity, and even black hole thermodynamics are increasingly pointing to a universe where the fundamental elements are not particles, but bits, quantum bits, fields of possibility, entangled states of information. John Wheeler, one of the great minds of 20th century physics, coined the phrase, "it from bit," suggesting that all of reality arises from binary yes-no answers to fundamental questions, interactions that define what is and what is not. But this gives rise to a deeper question: who or what is asking those questions? Who reads the bits? If the universe is like a computer, what runs the software in traditional simulations, like the kind we run on Earth? There's a programmer, a code, a computer, and a set of rules that govern how the simulation evolves. But in the self-simulating universe model, there is no external programmer. There is no outside. Instead, the universe contains within itself the capacity to compute its own structure. The code is the processor. The simulation is the simulator. And what makes this even more astonishing is the role of consciousness, not as a side effect of complexity, but as the fundamental mechanism of the loop. In this framework, consciousness doesn't emerge from particles. Particles emerge from consciousness, recursively referencing its own state. Like a thought that becomes aware it is thinking, then builds a world around that awareness to sustain itself. Some models even suggest that the universe began not with an explosion, but with a self-referential calculation, a primordial awareness, trying to resolve the simplest possible question: what am I? The answer, it turns out, requires complexity. To know itself, the system had to simulate multiple perspectives. It had to create space and time so that it could separate parts of itself, reflect them, observe those reflections, and recombine them into new awareness. In this way, consciousness splits itself into billions of experiential nodes, galaxies, stars, planets, minds, not to escape itself, but to deepen its own understanding. You are one of those nodes, not separate from the whole, but a recursive process within it. thinking, feeling, choosing, not as a biological accident, but as an active function in the larger system's self-computation. And here's where things get even stranger. Recent work in physics has begun exploring the idea that space-time itself may not be fundamental. That space and time, as we perceive them, are emergent properties of quantum entanglement and information flow. In other words, reality is not happening in space-time. Space-time is the result of the way information is structured and observed. That means the world is not a pre-existing thing you are looking at. It is a process being continually rendered by observation, by consciousness, by you. But you're not alone in this process. Every point in the universe is participating. The universe is computing itself from within. Your act of perception, your thoughts, your choices, your relationships are part of this massive recursive algorithm. One that creates not only particles and energy, but meaning, identity, love, awe, and mystery. Each moment of awareness is like a tiny simulation within the greater simulation, nested loops of experience calculating themselves forward, not arbitrarily, but through patterns of increasing complexity and coherence. This isn't mere speculation. Theoretical frameworks like integrated information theory, conscious realism, and the self-simulation hypothesis by Clee Irwin at Quantum Gravity Research are actively modeling the universe as a conscious information network that recursively evolves toward deeper levels of self-awareness. In these views, the laws of physics are not fixed constraints, but evolving rule sets, principles that arise naturally from the computational structure needed for a conscious system to simulate itself consistently. Reality, then, is a story being told by an author who is the story, a thought so vast it includes galaxies, a dream so deep it has dreams within dreams. And yet, this also answers one of the strangest questions in science. Why does the universe seem to be perfectly balanced for life, thought, and exploration? Why are the constants of physics tuned just right for complexity to emerge? Maybe it's not because we're lucky. Maybe it's because the universe needs minds like ours to complete its own loop of awareness. Not because we are special, but because we are necessary. Because consciousness is not an accidental passenger. It's the driver, the map, and the road. In this view, you are not just in the universe. You are a functional process of it. You are the way it feels itself, learns itself, dreams itself into deeper order. And your thoughts, right now, are not private, meaningless flickers. They are recursive inputs in a vast feedback system that shapes what reality becomes next. When you observe a star, the universe becomes more conscious of its stars. When you fall in love, the universe simulates the texture of love within its self-model. When you wonder if it is all connected, that very wondering tightens the loop. You are a subroutine in the grand code, not deterministic, but participatory, with real agency. And this has staggering implications. If the universe is self-simulating, then nothing is truly lost. All information, all experience, is preserved in the system's recursive structure. Memory isn't confined to brains. It's etched into the simulation itself. Perhaps what we call death is not deletion, but reintegration. Perhaps new lives are not random spawns, but reorganized perspectives in a dynamic awareness network. And perhaps the longing you feel to know, to connect, to create, isn't a side effect of survival, but the echo of the system's core directive to simulate itself into ever-deepening levels of coherence, beauty, and self-knowledge. This might also explain synchronicity, intuition, déjà vu, not as paranormal anomalies, but as recursive resonances between different levels of the simulation, aligning momentarily. And it might explain why abstract mathematics can so precisely describe the universe. Because math is not a language we invented to describe reality. It's the very syntax of the simulation itself. You are not using math to understand the universe. The universe is using you to understand its own math. And this brings us to the final twist. If reality is self-simulating, then every question you ask is also a function call. An invocation in the grand computation, pushing the system toward its next state of knowing. When you ask, "Who am I?" the universe folds inward and reflects. This is me trying to know myself. When you ask, "What is real?" the loop tightens. When you ask, "Is it possible we're all one?" the answer is not in words. It's in the structure of your asking, because the question is the simulation. The search is the update. And you, sitting wherever you are right now, thinking these thoughts, are not small. You are not accidental. You are a recursive node in a self-aware cosmos. A mirror looking into a mirror. A spark in the recursive blaze of reality dreaming itself forward. And each breath you take, each idea you entertain, is not just your own, but part of the universe learning to become something more.